that up. I mean, obviously, they always try to bring up, the Netflix hit piece or whatever, and I always have to kind of link to multiple different sections of Globe Bus, but that one's just so concise, and it's Bob's voice, him saying it personally. It's exactly the video that needed to be made. So thank you for that.
Toby made that. Toby's here. Toby, good job,
Thank
man.
you, Toby.
Yeah, thank you
Thank you,
so much
Toby.
for sharing that, man. And by the way, just talking about the divine thing, I I don't know, man. I don't want to get too into it, but it was an emotional thing to work on, and I will say I definitely felt guided to do it.
Hell yeah, because that's the best refutation to the casual dropping of a thanks Bob with someone doesn't understand the beginnings of the implications of interferometry, any of the experiments of the past. They just hear someone say it online and they're like, haha, thanks Bob. It makes
Yup.
me sick.
Yeah, it's what I've been saying about like Alan's work to people, and obviously based off of Robert and San Genesis, and everybody who has been doing such great work in the community. It turns that thanks Bob from a sarcastic thanks Bob to an actual sincere thanks Bob. You know what I mean? And
Absolutely.
I'm so
Yep.
grateful for Bob and for everything that he's done. So it's like it's so beautiful watching, and the more the more we look into it, the more it proves basically everything he was saying, right? So awesome.
Thanks. That's super edifying to hear. Thanks.
Yeah.
It's exactly the goal. And just for anyone that doesn't know the backstory, there was a film put out about flat Earth called Behind the Curve in 2004, or sorry, in 2018, and they took interferometry readings, or they took ring laser gyro readings. And the first reading they took measured 15 degrees per hour of rotation, and they edited that one measurement out, and they edited Bob Nadell to. They showed him being surprised by the one measurement, and then they made it look like he refused to accept what he had measured. But the truth was, he actually went and took multiple measurements at different altitudes, and there was a variance in what he measured by of up to 1.6 degrees, which is massive, and it cannot possibly be Earth rotation if there's that big of a variance at the same latitude at different altitudes, which also corroborates with Dayton Miller's findings. And yeah, the way that the film was edited, as far as I can tell, is quite slimy and quite dishonest.
Dude, that was a really good, succinct summary. Everyone's all caught up. But like,
Yeah, it really is like it really kind of outlines the satanic inversion trend of everything that is, the heliocentric model. Is they take somebody honest like Bob, who actually was man enough to confront the things that he didn't understand and be honest about them, and then they try to spin it around to make it look like he was dishonest and it proved their model when it was actually the exact opposite. That's a trend that you see just over and over again with what we're dealing with.
yeah, the way you can tell that people who criticize it don't understand it is like, oh, okay, when someone says thanks, Bob, I'll say, do you agree that the same measurements with a varying varying result at the same latitude at different elevation would be problematic? And they give you like the blank stare, and you're like, yeah. Even like the competent ones would be like, well, yeah, that would be a problem, but it's never happened, and no one's ever done it, and Bob's did is garbage, and no, 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 no. Like, okay, well, at least you agree that that is devastating for the globe. It's impossible. It's a physical impossibility for the rotation to be caused by a tangential velocity that varies at altitude. It has to be the same no matter what altitude or the same latitude. That's the dependency.
Exactly. Exactly. And the I really, really like that we'd uncovered um, Robert Bennett. I was hoping maybe this presentation you might even go in a little more in depth of the Wang experiment, because that one is just so great. Because the number one excuse that I always get is, oh, well, no, laser interferometry just can't measure linear velocity, but it can measure the orbital velocity, which is contradictory on the face of it. But having the Sagnac linearized like that and being able to show them that, um, that's just amazing. And I love the way Bennett, you break everything down. So and I know you have kind of gone into depth on this in previous conversations, but if you wouldn't mind just kind of hitting on that point again, and maybe just giving a concise overview of that experiment as well, again this time, so I could clip it out and use that in future debates, that would just be awesome, um, if at all possible.
If we have the time, sure.
Yeah, let me
Thank-
pull up some graphics to go for you.
Really quickly, I just wanted to commend you as well for having the cojones to stand up to your peers and the community that you belong to in the face of almost certain ostracism for what you believe to be the truth. So thank you so much for that.
Well, it's all about the truth, right? So go with the truth.
People of their value structure, they'll put a lot of stuff above the truth, and it seems like you're one of the few in that community that actually didn't do that. So again, just a lot of respect, love, and gratitude for you for doing that. And because of your work and Sangenis's work, laser interferometry has become kind of a cornerstone of so many of our arguments that lead people to realizing they are at the center of the observable universe, which is proof of the creator, which does mean that they are special. Their decisions have meaning, and it's kind of a snowball effect that makes the world a better place. So much love and gratitude for all that.
Well, thank you. The battle that we're fighting is against people who I think have been educated beyond their intelligence. They seem to think that if they have heard something from someone they consider to be intelligent, that they don't have to use reason to figure out if what was stated is true. Basically, if you know the truth, you shall be set free.
I love that. People have been educated beyond their intelligence. That's
Well
that's the
said.
best way I've ever heard that put. Right, as soon as I heard it, I'm like, "Yep, oh, I know. Yep, that's exactly the problem."
Yeah, it kind of reminds me of that Tesla quote, right? Like one must be sane to think clearly, but one can think deeply and be quite insane. And today's scientists have substituted mathematics for
Yep,
experiments, and they wander off through equation after equation,
with no
eventually
resemblance to
building a
reality.
structure which has no real. Yeah, because that's what relativity is, right? It's
Yep.
all abstract, and it's all to cover up the actual experiments.
Yeah, that's like the bombshell.
Math-
That's like the physical implications of it.
Yeah.
Mathematicians have taken over physics. That's the problem. Everything is abstract, and they've departed severely from experiments. And that's where we are today.
And that's why we have to go back to experiments to bring people back to reality, to get a whole
Yeah,
bunch of
because
people who believe in nonsense to actually hold on to some truth.
Amen. Because even like George Ellis, even like what he was saying about how like a lot of physicists will openly admit, look, it's philosophy. That's what we're building our models off of. And even back then, they were saying it's being covered up. They were kind of flashing the warning signals. And today, it's just almost Orwellian with their ability to cover up the fact that it's philosophy.
Memory hold that right into the hole. Poor guy.
It's the barn wall where the rules
Yep.
are written in the Animal Farm. It's they can change it with now that everything's online, and people that just have been conditioned to go to Wikipedia to write all of their essays during school, they don't know the difference between what's written
Yeah.
online and what the truth is.
That's a good point, man. Wikipedia kind of has all the worst information on it, and you only start to realizing that when you start to look at real truths or stuff that happened over the past like 3 years, and then you figure out, oh, Wikipedia is full of shit. They just perpetuate the same narrative as all the other. Oh, so it's just Google and YouTube as the same thing. Oh, I get it.
Yeah,
Yep,
absolutely.
exactly.
All right. So you said you wanted that quick rendition real quick. Let's run that and then we'll get on with the Aziz video. Whenever you're ready, Robert.
Okay, what do you want me to do?
He was asking about could you give a quick rendition of the Wang generalizing the Sagnac effect and then all that kind of stuff.
Okay,
yeah.
you want me to do that now?
Yeah,
all right.
if you don't mind.
Alan, can you get the slide from the scientific propaganda, the Wang slide?
Yep.
Isn't that the? Oh,
And
So,
that's while I'm talking, so that
yep.
I have something to refer to.
Mhm.
Okay, the background is that Sagnac effect in 1913, only 8 years after the 1905 special relativity paper by Einstein, was deliberately done. The experiment was deliberately done to show that light speed is not constant. And by using the rotating disk with two light beams, two half beams, traveling in opposite direction around the rotating disk, he showed that the speed of light is c plus or minus v. Plus is for the light beam that's boosted by the rotation, and the minus by the beam in the opposite direction. Now, this was criticized as not confirming or not corresponding with special relativity, because special relativity allegedly does not work in accelerated reference frames. And a rotating object is an accelerated reference frame. But Einstein himself had said, if you consider a polygon of n sides and you send a light beam around it, then it travels in straight lines on each side. And if you neglect the time that it takes to change direction at the edge of each, at the connection of each side, and you let n go to infinity, then you have a circle. So Einstein said, yes, motion in a circle does come under special relativity. So there's that, right? But then there was the demand for proof with a linear motion of a light beam rather than rotating. So I forget the name now.
Wang.
Yeah, that's I
Yeah.
drew a blank there. Wang decided to set up a conveyor belt with the interferometer placed either on the lab table, which means it's in the earth frame, or to put the interferometer on the conveyor, which means it's then on the conveyor frame. When he did that, he is testing two different reference frames, the lab frame and one which is in motion with a speed v. And the speed v is easily measured. You just measure how long does it take the conveyor to move down the track. So we have two frames that are being compared. What he found was that the speed of light measured by the interferometer on the lab table or on the conveyor, they both were c plus v. Okay? Now, first of all, that eliminates the second postulate of relativity. Because the second postulate says that the speed of light is c. So both in the lab and on the conveyor, we have a disproof. C plus v is found in both reference frames. What's most interesting, at least to me, is that what you should read on the conveyor is C, and yet we measure C plus V. What that means is we get the wrong answer when we are on the conveyor frame, when we're in the conveyor frame, and we get the right answer when we're in the lab frame. That turns out to be the same conclusion that we can get from the Newton's bucket experiment. In the Newton's bucket experiment, the lab frame is correct in predicting the vortex formed by the water surface, and in the bucket frame, we predict that there will be zero force on the water, and yet there is a vortex formed. So what I'm saying is the Sagnac experiment, the Wang experiment, and the Newton's bucket, all three of them show that in order to predict correctly the results of a physics experiment, that is, to use the laws of physics, you must use the lab frame. You cannot use anything else. So this, of course, is a great contradiction in physics, because we have the cosmological principle, which says the Earth is not special. It's just a tiny planet with a orbiting a know-nothing star in a out-of-the-way galaxy. And this principle, called the cosmological principle, is refuted by all three experiments that I mentioned, the Wang, the Sagnac, and Newton's bucket. If you want to know anything more about Wang's experiment, let's hear it.
No, that was great.
Dude, that was awesome.
That'll be a clip tomorrow when Toby makes that, puts it into. If
Yeah.
anyone asks for the Wang again, we'll just have to refer to him to this quick,
Yeah,
succinct
we-
rendition.
We
Yeah,
can now
thank you
give
so
them
much
the
for that,
Wang.
man. That covered it perfectly. Thank you.
Awesome.
Okay.
And so,
All right,
my
cool.
understanding is, just real quick, if they want to try and claim that Michelson-Gale is rotation, then what Wang discovered in 2004 is a major problem, because we should also be able to definitively measure orbit, right?
Yeah, I would say that the crucial argument to be made with Michelson-Gale, and with the Foucault pendulum for that matter, the critical logic to use there is that you are making measurements, which is kinematics. And when you make measurements, the law of relative motion is valid. You measure whether something is moving away from you with a certain speed, and that object will measure you as moving away at the same speed, and so on. You cannot prove if something is moving or not using measurements. You have to use dynamics, which is predictions using laws of physics. Okay, Michelson-Gale is a measurement of relative motion. The question is it the Earth that's rotating, or is it the ether that is rotating around a stationary Earth? The experiment cannot decide which is which. It can only be done by applying a law of physics. In the case of Newton's bucket, what law did we apply? The law of centrifugal force, which says that a rotating object will be subjected to a center fleeing force, which is proportional to the mass times the speed squared divided by the radius. So there's a law that we can apply, and we find that it fails for the bucket. We can't do the same thing for Michelson-Gale because, again, it's a test that cannot produce any results as far as which one is moving.
Interesting. That's super interesting, because the crux of our argument and our position has centered around this interpretation of this measurement of motion, right? They've always been measurements of motion. Other people in our community have discounted this motion, I think, to our detriment and to theirs, to try to argue a way around it. But it's always been that motion. It is the motion of the ether to us. But the only two possible interpretive frameworks in which to interpret the measurement of that motion is stationary Earth, rotating ether, which is us, or rotating ether, stationary Earth, or rotating Earth, stationary ether, right? Could anyone think of another possible frame of interpretation? Those are the only two, right?
Yeah, well, no, those are the only two, yeah. But there was something I wanted to add on to. So the distinction that they try to make about interferometry. So both interferometers, an orthogonal setup and in a closed polygonal circuit, as Einstein put it, both measure the same thing, but they try and say that the orthogonal one can't measure linear velocity and all these things, blah blah blah, but it's clearly measuring it. They just didn't get the numbers that they wanted. So that's the thing. That's where they get into the transformations for
Hmm.
the orthogonal setups.
I haven't heard about those.
Yeah, the classic Michelson-Morley.
Oh, so that
setup,
is what that is. Okay, so they don't.
Yeah, yeah.
Do they have a transformation for the ring laser gyro? I guess they don't need to because they just claim its rotation.
Right, that's the thing. That's exactly it.
Whole thing,
So
yeah.
so
That's
they're
so
like, oh yeah,
insane.
we get this first order velocity dependence and based on the area of the apparatus and the rotation, and then but for Michelson-Morley, they're like, oh yeah, we got to link contract and change coordinate systems, boys. Like what? But they don't do that for this. They just like mention it here. But they it's crazy, dude.
Well stated.
But yeah.
That really helped break that down for me. Thank you.
Yeah, no worries, bro.
What are we looking
It's
at here?
crazy once you see it because they've convoluted it so hard in the mainstream where it's separated between linear and circular interferometry because they need that circular effect to explain to explain the Sagnac effect to young relativists these days, because they don't really tell them about what Einstein said about the closed polygonal circuit. Like they all explain that away or like forgot about it or something. It's kind of crazy because when you bring it up, they're like, "Oh no, that's not an inertial frame," even though it's clearly defined as one.
Maybe I can give you guys a simple example that you could use in arguments like this. Suppose you had a child on a carousel and the parents are watching. The parents say, oh, the carousel is rotating, and so the kid is rotating with it. The kid, though, on the carousel says, no, I see my parents rotating around me, and that's my point of view. So if we ask which one is right, the answer is neither one is right, and neither one is wrong. You cannot decide which is in an absolute state of rest. It all depends on what your reference frame is. So if you use some kind of a model like that, you can simplify what seems to be a complicated experiment, Michelson-Gale experiment. It still comes down to measuring the relative speed of light compared when measured on Earth, which is what they did, compared to measuring it with the assumption that the Earth is rotating and the Æther is still. Does that help or not? I mean,
yeah, that's basically that's basically Newton's bucket right there, right? I mean, kinematically,
yeah,
the
exactly.
child
And
on the merry-go-round. Go ahead.
Right. And Foucault's pendulum, same thing. They say, oh, the plane of the pendulum is rotating. Therefore, it shows that the Earth is rotating. No, it doesn't. It could be the Æther that is pushing the pendulum bob. The Earth being at rest and the Æther in motion is just as valid an explanation as the one that is claimed by mainstream to say that it's the rotating Earth that causes the plane of the pendulum to rotate.
So let me see here. So the translation of motion from the motion of the ether above is physically causing the axis of rotation of a pendulum to change. Is that the argument?
But the plane of the pendulum, yes. Think of the Æther as though it were a wind, right? Like an air. If it were pushing, when the pendulum swings south in the northern hemisphere, then it's subjected to a slightly stronger Æther flow because the Æther is basically strongest at the equator and zero at the poles. If it's maximum at the equator, then the southern end of the pendulum bob gets a slightly greater force from the Æther than when the pendulum bob is in the northern part of the swing. So it's like each swing of the pendulum causes the pendulum to rotate clockwise, and that's what is seen in the experiment. It doesn't prove that either one is at rest, either the ether or the earth. Again, it's kinematics. It's a measurement, not an application of a physical law. It's not dynamics, it's kinematics.
Also, I would like to
Excellent.
chime in just real quick. Calling it a translation of motion from the sky is maybe a bit more presumptuous than we want to be, because it could be manifesting in a more 3D shape that's kind of pulsing with the equinoxes and has its own, even kind of its own rotations, vertical rotations, even possibly.
Yeah,
You're
I'm just
talking about like with Miller, how he measured the maximum and minimum dimensions of the ether winds peaking and receding at the equinoxes. Is that what you're referring to with the pulse?
Yep, and then also just we don't have enough measurements at all to really know what the shape of the flow really is at this point.
right. No, but like before we knew any of this stuff, and we met Alan about higher level interferometry measurements that corroborate all of this, we were trying to justify a Foucault's pendulum before, and we had lightly leaned on this loose, like vague translation of
Dude,
motion from the
yep.
sky down. You remember, like that's
Oh
where
yeah,
we were at
no,
with it.
no,
So now,
I think it's a good starting point. I think it's a good starting
Yeah.
point, but I just also, the more I've been thinking about it in recent weeks, the more I'm thinking, it might not be quite so straightforward.
Right. No, I mean
Yeah.
with the pulse and everything, but and the equinox, but I'm just trying to think about it in terms of trying to explain it to like a globe lad who's like, nah, it doesn't work, and you're like, okay, well here's what happens, right? The sky moves, and then this axis of rotation adjusts. It's a hard argument, I guess, is all I'm saying.
It's always a hard
Yeah.
argument with them because they make
That
it
one particularly, though.
unreasonably.
Yeah, but when
Yeah.
you know the truth of the matter, that like it's not
Yeah.
like it could go either way, like so like it doesn't matter, like
Well, that's why what Robert said at the very end was the best way I've ever put it, right? He just succinctly said it's kinematics and dynamics again, and you can't tell, and it doesn't matter. You're like,
Yep.
okay, oh, that's perfect. Okay, I'll just say that. We'll get to the heart of it.
Yeah, but I'm
Dude,
just
go
saying,
right to the meat.
if we could, measure it at various altitudes, various latitudes, we may start to discover some kind of a shape, I would think.
Well, that has been done.
But to
It
what
has
level of
been
precision?
Well, pretty accurate. Radio signals were sent from San Francisco to New York, and then in the reverse direction. If the speed of light is constant, as in special relativity, there should be no difference. The speed of light is the same in both directions. But everyone knows that it isn't. Let's see, the right direction, it's faster when it goes from San Francisco, that is, goes eastward, than when it goes westward from New York to San Francisco. Now that occurs at a certain latitude, right? Suppose you go a little further south, you find out the delay is a little more. So that shows you that the ether effect is greater when you go south, and it's greatest at the equator. If you did further testing, you'd find out at the poles there is no delay because the flow of the ether is basically zero. This is well known. This is not something that would be contested by a mainstream. We also have the GPS. We have the GPS satellites who can send signals back and forth at altitude, and they get an even bigger delay because the ether circles are even bigger when you're in orbit around the Earth. And that again confirms that the ether is affecting the speed of light, and the effect gets bigger the further you get from the center of the Earth. So all of the experiments support the ether model and a stationary Earth.
Go figure. To the direct antithesis of what Wikipedia and the first page of Google will tell you.
Yep.
Yep. And not to mention, so atomic clocks are synchronized to an equation that basically just is accounting for the Sagnac effect. So in other words, they're just accounting for the relative speed of the craft, of like whatever whatever it's on, right?
Yes, once they subtract the Æther effect, which they call the
Yep.
Sagnac effect. Yes,
There
that's
it is,
right.
there. That's from Paul Marmot, 2000. This paper right here breaks it down. So he goes over these equations here, and then at the end I have it highlighted. So he goes over. He says, we see that the GPS correction for clocks, equation 24, given here, looks a little relativistic to me. But then it breaks down to what he says that it's on what was it, equation 13, I think. It all reduces back to just the classical mechanics effect. That's not a relativistic effect at all. Yeah, they're just subtracting the Æther effect.
Yep. Mathematical disguises.
Turns out moving through the ether causes electromagnetic retardation. Who'd have thunk it? Allegedly.
It
All
literally
right.
sounds like a cover.
Well,
Sorry.
and just really quickly, if I'm not mistaken, it's a refutation of relativity if you could just show the variance of C to begin with. So that's kind
Yeah.
of that. That's always been
whole
kind
point.
of my. That's always been my view on RLGs and Sagnac to begin with. Is that if an object's velocity can't be added or subtracted from the speed of light according to relativity, then there would never be any change in the fringe shifts, and RLGs wouldn't work in the first place. They require Æther and the variance of C to begin with. So that's why I was so stoked when this Wang experiment surfaced, because their one kind of get out of jail free card with that was, oh well, it's that's not linear. Well, now we can prove that it's been linearized. So I mean, I don't know what your view is on that, Robert. If I believe if I'm quoting you correctly, that's basically what you would say as well. Is that would be a invalidation of relativity as well, just the fact that Sagnac exists in the first place.
Sure. Any experiment that shows that the speed of light is not C
Yeah,
is
B plus D. Yeah.
it's a disproof of the second postulate. I have a question. What's RLG?
Oh, sorry,
Ring
ring
laser
laser
gyro.
gyro. Yeah, just
Okay, got it.
yeah. RLGs and FOBs and MMXs are just I've learned to abbreviate them to make my arguments a little bit more concise when they run a little bit long.
All right. All right, cool. So we all wrapped up on that?
Yeah. What is this? What are we looking at?
Yeah. So we're gonna get to Bennett wanted to cover this conversation between André Koch Assis and Alexander Unzicker, where they're discussing relational mechanics and some experiments that invalidate um, Assis's position. And Bennett reached out to him to find out his to correct him on that, and he just basically hand waved dismissed him. So I'll let you take it from there, Bennett, if you want to recap it, and then we can get right into it. I got the timestamps loaded up. Just let me know when to stop playing.
I'm not sure I'm on the right screen. I'm on role selection.
Oh, 1 second.
You gotta watch
Is that
Alan's stream.
Um,
You gotta go to Alan and then watch stream.
okay?
The orange live button.
No, that's not it.
Like if you click on Alan's name in the chat over here, where you
So
hover.
many icons here. Okay, I have voice connected in green. I have
Above
friends.
that,
Find
and
or
like
start conversation. Friends. Add friend.
By scrolling up, if you're zoomed in too much, you might want to scroll up. See, and
yeah,
it might pop
now I
up.
don't know
It
where
should
he's
say
at.
Alan with a big red live button next to it.
See, I think you're not in the Æther Cosmology tab. You're in your
Yeah, it's hard to
Discord
know where
tab.
he's looking at. We gotta get him in the Ether Cosmology in the live voice chat. We gotta find Alan. The long list of names where everyone It's here.
Yeah. Yo, Robert, if you look to the left-hand side of Discord, do you see
Yeah.
like a little circle with a green icon on it?
Oh, yeah.
Okay, if you click
Explore.
on that, oh shoot, wrong circle. So the circle will have like the Aether Cosmology logo. It looks kind of like a what
Yeah,
does that
well,
look
that's the
like,
second
Toby?
one, the blue. It's a blue
Oh,
disc.
Yeah.
yeah. Click on the blue disc one. That should take you back to
I was
here.
on that.
Oh, okay. And then so in there, can you see like the group chat where people like the list of people that are in this room?
Like halfway.
No, I see. I
It's in the
see
middle.
a lobby and then
Oh, scroll down.
rules, role selection.
Yeah, you gotta scroll
Okay.
down. It's about halfway down.
Scroll down. Oh,
Yeah.
Yeah.
okay. Now I see Alan live.
Perfect.
There you
Yep.
go. We'll do it live.
That was a good group effort, guys.
We all came together as a squad, dude.
Good
That's
job all
what's up.
around. Yeah.
Squad goals.
It wouldn't be a round
Now,
table.
how do
for
I make
nothing.
that? How do I make that bigger? It's in the lower.
Click on it.
If you double click on it, it should.
If it's in a corner, if you click on currently live, it'll maximize it.
All right. Yeah. Okay.
Rocking on.
He's in.
Cool.
We're in.
All right, you ready to roll?
Yeah, he's in.
Yep.
All right, cool. All right, I got us paused at 5 minutes 52 seconds for our first slide here. So the annotation is Newton, absolute space means empty space, question mark. There's our preface. Was there anything, or you just want to play the clip and then go over it?
Oh, okay. I thought you would display the text that went.
Oh, that went with
this.
it? Oh yeah, I could do
Yeah.
that. I could do that. Absolutely. I didn't know that. Yeah, no problem. You guys see that?
No.
Oh, hang on. I know why.
All right. Well, what happened was I was watching this talk.
There we go.
This video. The title is Mach's Principle. And as Alan said, I sent a letter to them describing some of the problems I had with it, and I didn't get any answer from Alex Unzucker, and I got a dismissive response from André Assis. The video was an interview. Alexander Unzucker is well known as a dissident in particle physics. He worked at CERN in Europe, and he was disillusioned with the way they did their experiments and the logic that they used. And so he has become a vocal critic of mainstream. And André Assis has written a book called Relational Mechanics, which is a replacement for relativity. He tried to blend kinematics and dynamics into one theory, which is theoretically virtually impossible to do because kinematics is measurement and dynamics is prediction. And those are two distinct fields. If you go into physics, you either choose experimental or theoretical. So you can't do one. You have to do one or the other and try and blend the results together. Okay, so what I put together is a video that we're going to see clips from, and then I'm going to respond. And I don't know, Alan, can you make that screen bigger? Or maybe I can with.
Let me
No, I can't do it with.
Hang on. How's that?
Yeah, big enough to read. Yeah, that's
No
good.
problem. I'll just adjust it as we go. No problem.
Okay, so what I'd recommend is I gave the link to Alan, so if he shares that with you, you can look at the entire video at your leisure. You can even speed it up to 1.5 so that it doesn't take over an hour. It would take maybe 40 minutes if you speed it up. And all I'm going to do is hit the high spots as it were, and I think we're ready to roll the first clip.
Okay. All right. Here we go.
Anything circulating around a current carrying wire. So if this is wrong, so what did Ampere do? That is your.
But you would consider that in first place a historical detail, because the original formulation is sometimes not as pedagogical as it should be. Is something that can be overcome, or is there something fundamental
Yes,
in it which is fully appreciated? I mean,
Yes,
you won't argue that the concept.
Is that too fast?
No.
Oh, that's
A little bit, yeah.
Maybe 1.25.
I think-
Assis is hard to understand.
1.25 maybe?
Yeah.
His audio is just bad though.
Of a magnetic field does make sense, doesn't it? I mean,
yes, but Ampere didn't work with this concept.
Yeah.
Perfect.
That is the first thing which must be very clear. And in the second place, he was explicitly against anything circulating around a current carrying wire. Nowadays, everyone learns that if you have a wire with a current, then you apply the right hand rule and find the magnetic field circulating around it. Ampere was against anything like a vortex or a force or anything circulating. So it is very important that this should be correct in the textbooks. That's the first thing. Now let's go to what Ampere really did. What was his main insight? So in 1820, the Danish scientist Ørsted, for the first time, he saw an interaction between current and a magnet.
Alan.
The current in a wire.
Yeah.
You know what happened? We've got the wrong video.
Oh,
What
no.
Oh, really?
What I sent you was the Mach's principle in the second. In the second email. The way this got confused is, you see the picture that's on the screen?
Yeah.
That's shown as the thumbnail for both.
Right.
For both videos. So when I saw it, I clicked on the video for this electromagnetism. That's what they're talking about. But it's the Mach's principle link that we need, and unfortunately, they have the same thumbnail on the to identify the link.
Well, this guy, Unzicker, aggressively agreeing is already annoying. I don't know about anybody else. the amount of time that he was like, I was like, give him a chance to say the thing before you agree.
They kind of get into counter space in this one, as far as I could tell. It was interesting.
Yeah. Okay. Unzicker is.
I found it already. It's in the. Yeah, it's in the side chat.
All right, no worries. So here we go. 5 minutes and what was it? Hang on. 5:52.
Oh, maybe he has better audio in this one. I hope so.
God, I hope so. That shit was atrocious.
So yeah, it's bad to see these like PhD doctors with like echoey garage audio on the laptop speaker.
Yeah.
They're like, oh man, I gotta listen to this through like a kid's iPhone. Come on.
Are you guys turning up their audio to 200%?
I did.
I am now.
Yeah.
All right. Let's see here. Playback. Go 1.5 and see how that goes.
It's still showing the same.
Yeah. Oh, so are we watching the guy who was like a dissident and worked at CERN? Is this one of these people?
Yeah, the one on the left,
Unzicker, the one I
Alexander.
hate. Okay, all right, good. That's bad because
Well,
I
and
want to feel
Aziz,
like him.
and Aziz is trying to. He wrote a book that's trying to get away from relativity.
Okay. All right.
These are the eyes of a man that's trying to steer us into madness.
That's the
Like,
soul, huh?
just a heads up, like I no longer trust him or will be citing him for anything.
I didn't
Anyway.
think that at all. I promise.
All right, here we go.
And he knew that this concept was problematic. And even Leibniz, they attacked these ideas of empty space. How can you refer motion to something which is nothing? So Leibniz said, no, you should only refer motion of one body relative to another body. They can approach or move away, but not something moving relative to nothing. So that makes no sense. Not only philosophically, but also practically.
I did not know that Leibniz came up with that objection. I thought the first one was Bishop Berkeley, but so Leibniz was a precursor in that sense.
Yeah, sure. There is a very famous controversy between Newton and Leibniz, but
they had many also
exchange
on
of letters.
calculus, but
in this case, Newton was represented by Clark, one of his friends, and so there is this Clark-Leibniz correspondence and so on. It was at the end of Leibniz's life, but very deep, very important. But Newton knew that this concept of empty space,
Alan, I think we can
which
cut
we call absolute space, was problematic.
Alrighty. Thanks, Unzicker.
All right. If you caught the gist of that, they were claiming that Newton's absolute space is interpreted to mean empty space. But wasn't the empty space interpretation an indication that Newton didn't whoa, lost my spot.
Oh,
it happens to me like constantly.
That he didn't know like where absolute space was because he was a Copernican. So like I think that was where you were going with it.
Yeah. Newton's absolute space was an abstraction which said that there is a coordinate system in space somewhere, and that's why the water acts the way it does. Okay. But what Newton didn't say is, well, where should I put my observer in order to see this effect? He was in fact going into a modeling space instead of physical space. He wasn't connecting his idea of what causes the water not to obey his laws when he's in the bucket frame. So the earth frame does predict the motion of the water, but Newton doesn't directly connect the earth frame with absolute space. I do. My claim is that the earth frame must be used in order to correctly predict what the water will do. And that can be proven for many other experiments. So the empty space interpretation that these guys are giving is an indication that Newton didn't know where the absolute space was or how it was tested. The issue really was reference frames. Where do I place an observer to detect absolute space? Where should you be situated so it can be tested via the scientific method? Newton, in fact, said absolute space in its own nature without relation to anything external. But you have to have something physical in order to test it, according to the scientific method. The concept of inertial frame is also mentioned in this discussion. Inertial frames which are at rest or which move with a constant velocity relative to absolute space. And does absolute space, according to Newton, represent an inertial frame of reference? Well, no, because an inertial frame of reference requires an observer, and Newton never mentions that with his absolute space. So that was the first objection that I had to their discussion. move on if you want, or should we discuss this further?
They moved by it real quick. They did not care.
I can see why they didn't email you back. If they're yeah. If I got an email from you saying that exactly, just from that, I would stop reading it and pretend I never met you.
They were like, I just wanted to have an erudite conversation with people about nonsense philosophical guesswork. Why you gotta bring down my buzz?
Yeah, it reminds me. I actually did see somebody was trying to debunk Newton's bucket by referencing one of his follow-up thought experiments that he did. Bennett, are you familiar with the one? I'm sure you are, where it's two balls attached with a chain or a spring, rotating
Yeah.
around each other. Yeah, and the guy that was presenting that basically said, well, so if you rotate both the balls, then they'll pull apart, and so you could tell. That's kind of like a Newton's bucket experiment based on whether the spring was, whether the spring was enlarged or shortened, whether it was moving or not. And then the person was saying, but you would have to be on Earth in order to know. You would have to measure, first of all, the length of the spring while at rest. So that just proves that Mach was right and Newton was wrong, because you need Earth in that scenario, which is what I was watching. I was like, are you kidding? Of course you would need Earth, because that's where the experiment would be performed. It just absolute nonsense to me.
Yeah, I think the point of using the balls on a spring is to get away from using the water. Some people, when they want to discuss the Newton's bucket, they get fixated on the water and the effect that centrifugal force has on the water. The purpose of the water is only to detect if there is a force acting inside the bucket. And that's what the vortex formation shows. Now, Newton could have used a spring, a horizontal spring attached to the axis of a motor, and the vertical axis of the motor would be set into motion. And once again, you would have the same situation. If you have measurements in the bucket frame, you would say, I'm saying if you're using a spring now instead of the water, if you see the spring extended, then you know that there's a centrifugal force. Well, you would see that if you set the motor running, and that would produce the centrifugal force. But according to, but if you were in the bucket frame, you would be rotating with the motor axis, okay? And in that frame, then, you would say that the spring is at rest, and it therefore should not be extended. It is extended, just like the water forms a vortex when it shouldn't. So the same experiment with different setup shows the same thing, namely that the laws of physics don't work if you're not in the laboratory frame. I have some diagrams later, I think, some diagrams of what they used instead of water. But don't get confused. The water is only used to detect the presence of a centrifugal force. You could use anything else. It doesn't have to be water.
So is that the crux of your argument, Robert, about the lab frame? Essentially,
yes.
The laws of physics do not apply except for in the lab frame.
Exactly.
Yeah,
and that's dynamics. Now, don't quote me as saying if you measure something in the bucket frame that it won't be correct. No, that's kinematics. When you measure something, it's kinematics. You're using a law of physics like centrifugal force law to predict what will happen. That is dynamics, and it's in dynamics that you must use the lab frame.
Gotcha.
That pesky lab frame.
That's
Turns
it.
out every time they keep coming back to that, every experiment determines the same result every time and time and time again, it seems.
Dude, the absolute reality frame, some would say.
Dude, that's a good way to put it.
Dude, shout out to Xavier in the chat. He said that.
The absolute reality frame.
Yeah, let's call it that from now on. All agreed.
Awesome.
Do you like that
All
one,
right.
Robert?
Yes, absolute truth frame, absolute
Ooh.
reality.
For sure.
All right. So ready to move on to Newton's bucket part 2?
Look at this. Categorized itinerary table of contents with a bolded out, sectioned off part 1. Here we go.
Yeah. Oh, shoot. 1 second. There we go. Sorry, I have to keep switching these because of so that you guys get the audio. Let's see. I think it was at 14. Yeah, 14 minutes. Cool.
The ears, of course, because here the water is at rest relative to the ground. And in this situation, the water is spinning relative to the ground. So we might say, well, the responsible for the concavity is not rotation of the water relative to the bucket, but rotation of the water relative to the ground. But then Newton argued that this is not the case as well. Why not? Newton proved that the earth is essentially spherical and it attracts everything towards the center of the earth. And this happens, this is just the weight of anybody, which is downwards.
We could do even this experiment at the ISS space.
Yes,
right?
that's possible.
There would be no attraction, there would no be pressure, the water would be just out there at the cylinder.
The water would become at the wall cylindrical if we are in space.
Yeah, all this is not the real problem. The
yes,
real problem comes.
So why Newton said that it's not motion of the water relative to the ground? Because even when the water is spinning, the force which the earth exerts on any molecule of water is always pointing downwards. There is no horizontal component.
Of course.
No matter if the water is at rest or spinning, because Newton's law of gravitation does not depend on velocity nor on acceleration. So we eliminated now the second material suspect, which is the earth.
All right, you
ground.
can cut it, Alan.
So there is a third and.
Alrighty.
Okay, so now he's going into what is the cause, right?
Mm-hmm.
We know what Newton's bucket represents. It represents a problem because you can't use centrifugal force law if you're not in the laboratory frame. All right, so the cause that he's discussing is the bucket. Does the bucket cause the water surface to form a parabola, even when the bucket observer measures the water at rest? Well, the bucket observer measures the effect of a horizontal force, and that effect is the parabola or the vortex that the water forms. But Newton's law of centrifugal force predicts that there's no force if there's no rotation. So this implies a contradictory distinction between the application of kinematics and dynamics. That's basically what I've been saying for the last 10 minutes, that you must use a distinction between kinematics and dynamics. And when you're in dynamics, only use the lab frame to make predictions.
Well, we're back at the lab frame. Is anyone here surprised? All right, awesome.
Nope.
All right.
Could I? Well,
and
I was just gonna ask a question.
And
yeah, go ahead.
There's religious overtones here, of course, with saying that the Earth is special because only the laws of physics are valid when you're in the Earth frame, and so there's implications here beyond science, into philosophy, and up into theology.
Well, that goes against their philosophical/scientific belief. Sorry, go ahead, Beasticles.
No, you're
Yeah, what
good.
about the Copernican principle? I mean, I thought we weren't special.
I agree with what Robert says though about, it has to be done in the Earth frame. It's all we know. This is where we live, what we experience. So even on a, in a thought experiment way, it's like, have you ever been to space, Robert? No. Have I ever been to space? No. So even at a like relative level of like what can we actually test and measure, we have to use the Earth frame. So yeah, I agree.
All right. Did you have anything to add to the spinning bucket? Or no, yeah, you already went over that actually. So what was the next one? 1525. So recap into the bucket.
Yeah, this one they're going to go into the second cause that they think explains Mach's principle.
Oh, we're actually like already a little bit into it. So let me switch here and then I'll just back it up a little bit.
Second pendulum even downwards.
1525.
There is no horizontal component.
Of course.
No matter if the water is at rest or spinning, because Newton's law of gravitation does not depend on velocity nor on acceleration. So we eliminated now the second material suspect, which is the earth, the ground. So there is a third and final material suspect, which is the remainder of the universe, the stars and galaxies. Newton didn't know about galaxies, but we know, okay? So we might say,
and not even Mach about galaxies.
Not even Mach, because it's only with Hubble that we could decide the question.
I thought
in this situation, the water is essentially at rest or not accelerated relative to the stars and the galaxies. But in this case, the water is spinning relative to the stars and the galaxies. So we might say this is responsible for the curvature. But then Newton said, no, this is not the case. How could he know that? Because Newton was so brilliant that he made a very important calculation in his book, Principia.
Yeah.
It showed not only that a spherical shell attracts an external point as if the shell were in the center, but he also calculates the force exerted by a.
Yeah, we don't need.
Hello,
yeah, that's good.
I'm Patrick.
What up, Patrick?
YouTube added. God damn,
Hollow
dude, glad
shell.
you're
Yes.
using Brave.
Brave and U-block origin, man. Come on.
Jeez.
It's all good, dude. All right. So, did you say that was good to cut it on, Robert?
Yeah, that was.
Look where you
That's
paused
good.
it, though. That was crazy.
At a skip. Yeah. Yeah, they're discussing the possibility that the Earth or the ground could cause the effect, and the water moves horizontally, but gravity is vertical. So they're saying the Earth is not the cause. And my claim is that it's true. Gravity is not the cause of the anomaly, but it's the lab observer, Newton, who correctly predicts the parabola formation, the vortex, that's measured using the Earth reference frame. So André is saying that he's eliminating gravity and he's eliminating the Earth as the cause of the effect. But what he's missing is the fact that you must be in a reference frame, an observer who is on the Earth, in order to see this effect, in order to correctly predict the application of the law of physics. And so they seem to eliminate the lab frame, but they don't really. He's eliminating the Earth, the gravity force of the Earth as being vertical, and the effect that he sees is horizontal. But I'm saying that that is misplaced. The correct statement is that it is not the Earth, but the Earth's reference frame that causes this effect.
Yeah, see, and you'd say the same thing is applicable to the balls on the spring as well, because that's what what actually I was talking about earlier with the video was trying to imply is that the Earth's gravity was responsible for the Newton's bucket effect, because without gravity of Earth, then you wouldn't get the vortex to begin with. So if you take that away, you could take hypothetically, in the alleged medium of space, you would have the two balls in the spring, and then without Earth's gravity, you could do the experiment that way. But basically, if I'm hearing you correctly, what you would state is that the Earth's reference frame or the lab frame is what you would require to have the experiment done in the first place, correct?
Right. You would see the same effect. That is, you would see the ball spread out, stretching the spring, even if you did this on the space station. And yet, it isn't predicted because the space station and the rotating spring are in the same reference frame. They're co-rotating. They're rotating together. So it's the same argument. Even in space, you must use the lab frame.
Even in space, you must use the lab frame. That's going on a T-shirt. We're gonna start selling merch on that. Check out Æther Cosmology / Toby or whatever. Toby, you're on it, right? Like, get it.
I like that. Although I still
Even in
prefer
space.
space is fake and gay, which is like a direct contradiction to that one. I don't know if I can have both.
It should just say like I live here, and it's pointing to absolute reality frame, and on the back,
Yeah,
just
I mean, they
say,
both kind of say
even
the same
space.
thing.
Even space has to be in the lab frame.
All right, very cool. So always in the lab frame, just to double check and make sure we're all on the same page. Yeah, so when they get into not the lab frame, again, so this is only reified through covariant mathematics, which is a hypothesis waiting to be experimentally verified, as a wise man named Robert Bennett once said. So and that's
Heck yeah.
basically
Yeah.
what they teach people, how to calculate, and if they calculate it and you carry your 2 and you move your decimal places enough, like, that's reality now. That's kind of what they've beat it. That's kind of what they've beat into people's heads. Yeah.
Carry the 2, move the decimal spot. Oh, look, now it's bona fide Earth rotation. See that? Proved it.
All right. Was there anything else you wanted to add to that before we move on?
No, we can go to 2055.
Alrighty. 2055.
I wonder if either one of these 2 gentlemen are actually interested in a genuine critique of their work or discussions at all.
No.
Yeah, I don't get that impression. That one guy is not even letting the other guy talk.
It's 2055, by the way, Alan.
Would you say 2055?
Yeah. Like,
Oh, that's not 2555? Nice. Hell yeah. Thank you.
Give me a % of the T-shirt
Bring
sales,
as
right?
Absolutely.
like a third, right?
This could influence what we
Yes.
perceive as absolute space.
You are precise, Alexander. You are precise. So
Yeah.
Ernst Mach, it was an Austrian physicist. We usually think that he was a philosopher, but he was an experimental physicist.
Yeah,
And
of
he
course.
came 200 years after Newton.
Yeah.
And then when he did need to teach mechanics for medical students, so he did need to think about the concepts to explain to his students. And so he discovered that he himself was not clear. So he went back to the originals, and then he did disagree with Newton. He said it cannot be motion relative to empty space causing
Maybe we
the
can display
parabolic
that
shape
famous
of water.
quote.
No.
I will put that famous quote. It's like what would happen if the thickness of the walls would increase and
In mass
eventually
and so on.
hundreds of miles.
Yes,
And that's,
yes.
of course, I think this is a brilliant idea. I mean, if you hear it
Yes.
for the first time, it's like, wow. And then,
Yes, of course.
we're talking now we are talking of distant galaxies, but which were not known at the time. But it has nothing to do with the details of galaxies, but with the very concept that all the masses out there in the universe might have that influence and on what we perceive on absolute space, and in turn also on inertia and gravity.
Yes. And so Ernst Mach said Newton must be wrong. Mach, he knew that it was not the ground, the earth, that responsible for the curvature. As you said, Alexander, if we can perform this experimenting the space station and so on, it will not be parabolic because the Earth is not there, but the water will go to the sides of the the bucket, okay? And but Mach said Newton must be wrong from philosophical point of view. There is no motion relative to.
I would hesitate a little bit. I would say he said that Newton could be wrong because actually nobody can perform the experiment.
Yes,
let rotate the galaxies around.
Yes,
right?
no one can perform. But Mach said that Newton's absolute space, it was a monstrosity in physics that we must get rid of it.
Yes, he challenged that concept of absolute space, also of absolute time, by the way.
Yes, by the way, as well.
And that he challenged that for a good reason, let's say.
Yes.
That's okay.
So,
but the experimentum proves is...
I think that's enough, Alan.
He said...
Alrighty. Thank God. Whew. All right.
All right. Dude, these guys congratulate each other over and over again. Yes, yes, yes. Sorry.
Oh man. Okay. Yeah. Sorry. Go ahead.
We're talking about Ernst Mach. Does anyone know what Mach 2 means?
Are you talking about Ernst Mach?
Yeah.
Okay.
He gave his name is used in physics to represent the ratio of the speed of sound to the speed of an object to the speed of sound. So a plane that goes at Mach 2 is going at twice the speed of sound. You've never heard of that?
Yeah.
Yeah. No. Yeah. Sorry.
So I'm just saying, Mach. That's the same Mach, Ernst Mach, that we're talking about here.
Gotcha.
In Mach's principle, is the same one whose name is used for the speed of sound comparison. All right. Okay, Alexander, who's the one on the left, says that Mach's principle implies that distant mass could influence what is perceived as absolute space. So he's saying that the distant stars and galaxies can influence the water in the bucket and can represent what Newton meant by absolute space. So he's trying to connect everything together, but he's still missing the point that it must be the lab frame that is used in order to correctly predict what the water does. And if you're in any other frame, a non-inertial frame, then all bets are off. You will not predict the correct result if you're not in the lab frame. Now, there's a lot of misquoting that's being done here. Both of them are quoting Mach as saying that the effect of the water is due to the distant stars. Well, he didn't say that exactly. He said it was the Earth and the distant stars together that produced the effect. So he's partially correct. Mach said that the Earth had an effect on the result, and that's correct because you must use the lab frame. But he's not correct with the statement that the distant stars and galaxies affect the water in the bucket, because all we need is to ask, in any experiment, did you do the experiment in the lab frame? If you did, then you can use the laws of physics. If you didn't, you can't. You'll get the wrong result. They're trying to dance around and try and find an answer. Is it the Earth? Is it absolute space? Well, the answer is right in front of them. It's the Earth's lab frame, and that will explain everything. And by the way, my model is called ALPHA, A-L-F-A. The ALF stands for absolute lab frame. So that's one of the two components. The last A stands for Æther. So absolute lab frame and Æther is the acronym for the theory that I propose.
Very
Now-
nice.
Very nice.
Now that should be a shirt. But so when you say absolute lab frame,
Universal truth.
right.
Reality.
So if you were gonna actually go out and test something, would you neglect the laws of physics if you're not in the lab, or if you are in the lab frame? Or you would have to take those into account, but they only have to be taken into account in a lab frame? I'm confused.
Okay, if you're in the lab frame, you're golden, right? Because then you can use the laws of physics and they will work. They will predict what will happen. If you're not in the lab frame, then here's what you can do. You can ask somebody who is in the lab frame what measurements they will take, and then apply the laws of physics to those measurements, and you will predict what's going to happen in your reference frame.
Okay.
Complicated, right? But what I'm saying is, if you're not in the lab frame, then ask somebody or get the information somehow about what the measurements would be in the lab frame, and then transform the results into your lab frame, into your reference frame. So if you're in a satellite, for example, then what you do is you ask the ground station, what do you observe? You know, whatever you're looking at, whatever you're testing, and the ground station tells you what they observe, and you change that to your reference frame by adding your velocity, right, with respect to the Earth, and that gives you the correct result. But still comes down to you must use the lab frame, whether you're in the lab frame or not.
Okay. I'm starting to pick up what you're putting down.
Is kind of a simplistic way of looking at it would be like if you were to imagine Newton's bucket inside of a Newton's bucket experiment. And obviously the Newton's bucket experiment that's taking place inside of the Newton's bucket experiment would not be you wouldn't get the same results as Newton's bucket, because now you're operating, the laws of physics would be different within frame. Yeah, it's in a Newton bucketception type scenario, right? The Newton's bucket inside of Newton's bucket is not actually following the same, you're not getting the same results as you would get in the lab frame.
So
Robert, I don't know if that's a good way to explain it.
Right. No. So if I'm correct, you're just mad that these two keep ignoring the different reference frames. In a sense.
I'm mad that they.
Well, it's not just that.
Right. That's just colloquial terminology. He didn't mean like mad. He meant like so. Like your point of contention is that these two are missing the mark by just not acknowledging the stationary reference frame because of the implication. Because like they can't. Right.
That's what I'm picking up. Am I correct on that?
That's just how we talk. We say we refer to someone as being mad when there's a point of contention, even if it's not about them being like emotionally invested in it. But yeah. Sorry.
Okay. Yeah, the point is to use the lab frame in all cases where you want to make predictions. Either if you're in the lab frame, no problem. If you're not, then you have to get the information from the lab frame and then transform into your frame. One of the lies that we have from NASA is their claim that they do deep space tracking by using solar barocentric coordinates. That means a reference frame that's at the center of mass of the solar system. That location is somewhere inside the sun, but it depends where Jupiter and the other gas giants are. In any case, it's easy to disprove that they don't do the calculations of the spacecraft location using that coordinate system, because all of the antennas are on Earth. So all of the data is being collected on Earth. There are no antennas on the sun collecting data and sending it to NASA on at their ground stations on Earth. At the most, we would have antennas in orbit around the Earth. But easily disprove any claim that we're using Mars as a coordinate system, or we're using anything but Earth, because
right.
because only on Earth do we have the antennas, or as I said, in satellites that are orbiting the Earth.
Makes sense.
Yeah, but why doesn't it make sense to everyone else?
Social
yeah, that's-
engineering, programming, and what did you
that's-
say? Being educated beyond their intelligence.
It feels
That
like what
one,
we're
yeah.
doing is going through 100 different ways of basically just showing that theoretical physics don't tell us anything real. Right? I mean, they
Or
can
at
think
least not
theoretical
without referring
for
the
anything
Earth
about
like
the
a
lab
stationary
frame. It's all just measurements, as you've stated over and over again. And it feels like we're just hammering on the same point of just like everything that we do that's outside of, or everything we assert that's outside of this reference frame, which is only here on Earth, is there's no, we have no dynamic, nothing measured, nothing from a lab frame. Everything's measured from here, so it's all just kinematics.
Nothing that's not from a lab frame.
Mhm.
Thank you.
Yeah. Yep.
Yeah, it seems like mainstream physics focuses on twisting the truth in order to make it agree with their previously asserted principles.
Very much so.
Like,
Clip that.
Yeah, they're not looking
Yeah,
for the truth. They're looking for what they
Yeah.
already think to be told that's true. Like they want to be told and reassured what they already know is true. They're like, yeah, great, congratulations.
It's sad how much deprogramming we have to go through just to start doing real science.
it's
Yeah, and
been
just to touch on
120
the.
years.
Hang on a second. Sorry, go ahead,
Go ahead,
Bennett.
Robert. Go ahead, Robert.
Yeah, it's been 120 years since Einstein made his declarations of the special relativity. Since that time, all of the experiments that show that the speed of light is not constant have been twisted and turned and misinterpreted in order to confirm the fact that in their mind, if Einstein said it was constant c, and it must be c, and any experiments that we do that don't show that it's c must be defective, or our interpretation is incorrect. In other words, our philosophy, our method of discovering the truth is incorrect. So they have a mindset that what they've always been taught is the truth, and they can discover new truths, but they will not permit any of their cherished truths to be upset. And that's true of mainstream physics. A lot of people don't understand the basis for their beliefs, and so they go along with it.
Yep.
But you can't tell me the ones at the top, the ones who are publishing the textbooks and appearing on TV and making all of the wiki documents. You can't tell me they don't know the problem with the Newton's bucket. They have to know it.
But in their mind, it also
Otherwise,
has to be real, right?
Or is it a willful deception then in your mind for them, for the people at the top at least?
I think it's a question of, once they've attached themselves to something as being the truth, they're very reluctant to admit that they're wrong. So I think it's a question of intellectual pride, that I can't be wrong if I said, if I decided that whatever this physics belief is, that it's true.
I got a sneaking suspicion that somewhere at the top there's a definite will to deceive and dissuade people from finding the truth. But that's just my personal crazy opinion. So.
But I get what you mean, Robert. They have too much skin in the game.
Yep.
Yeah, that's one way to put it. Yeah.
Their identity is wrapped up in it.
Yeah, which is
Yep.
Yeah, definitely a case of ego identity.
20 years writing books, dissertations,
But that's
publications.
that's
and you're
these
wrong.
people,
Oof.
right? That's these PhDs who have like shows and like have like are professors at universities and give lectures and know each other. That's like the bulk of the scientific community. The people at the top, the people who like decide what can be said and what is part of the mainstream infrastructure. Those are the people that we should be worried about.
What
Yeah,
if
the
you've been
Rockefeller
teaching?
approved. I was about to say the Rockefeller approved curriculum
There
is
we go.
basically what dictates what's acceptable.
Yeah, amen.
What if you've been teaching 2 + 2 = 5 all your life, and somebody says, "Wait a minute, 2 + 2 = 4"?
You,
Okay,
you
what
would
are you gonna
immediately
do?
you would immediately keep teaching 2 + 2 = 5 because otherwise everyone would know I'm a fool. Gotcha.
Yeah.
Right.
It's a lot
Right.
of men.
Exactly.
Okay.
But yeah, continuing for sure.
Yeah, I guess a lot of people would just double down.
Yeah, it's that Saint Anthony, the great quote. He says, "A time is coming when men will go mad, and when they see someone who is not mad, they will attack him, saying, you are mad. You're not like us." I feel like we're living in those times right now.
That's a pretty
than
good
anything
quote.
else.
What about the one that's like the more smart people won't be allowed to speak for fear of offending ignorant people or something? I've definitely butchered it.
Saint Anthony, huh? Wow.
Yeah, Saint Anthony. Yeah, that one's I found very relevant to today's day and age. If you and I love that cartoon, the 2 + 2 = 4 and 2 + 2 = 5 protest signs. That one, I actually clipped that out and have sent it to a couple of people because I think that encapsulates the issue really well. People screaming at the top of their lungs the lies, and people are, we're just sitting here trying to get them to remember the truth.
Just remember it.
Yeah, well, we knew. I mean, even with regards to the satellites, with NASA, and most people in this room would probably, that'd be a point of contention that NASA's even doing that. But they have to use the geocentric equations even to make sense, even to make it plausible that they're doing that anyways. So whether you believe they're sending satellites where they say that they are or not, if they didn't do it from a geocentric standpoint, then their equations wouldn't make sense to begin with. So it's just further proof.
Right.
Further proof.
Yeah, agreed. Sorry to chime in a little late, but hope you all are well. And yeah, I agree. I think they're just hanging out on balloons, but yeah, completely.
Yeah, well, in order to, the most effective lies are ones that have, grains of truth sprinkled throughout. And I don't even know if it'd be possible for them to come up with an entire new mathematical heliocentric modeled equations to define what they're doing with those satellites. So they have to use geocentric equations. It's just further proof that that's the only way that this reality that we're in makes sense.
Yeah. All right.
Yep.
So we're at 26:05. If there was nothing else to move on from.
Main possibilities. But I will let the audience, each one, think about that. What each one of you,
let us know in the comments what you think about the experiment, which has not been done yet.
Yes, and this experiment, so each one can give any answer which he wishes, because this experiment has never been done and will never be done.
Yeah. However, there are other possibilities.
Other possibilities, but not this one, because it is impossible to rotate.
But the simple fact that, if you rotate it at a certain frequency, the outer parts of the universe would be superluminal motion. So you have already a problem here. But
anyway, it is impossible to rotate all the universe around the span once a second relative to the ground. So it is completely a thought experiment. So each one of the audience can give any answer, because no one knows the right answer, and no one will never know the right answer, because this is impossible, this experiment. It can suggest other possible experiments, but this one specifically, it is impossible to do it, to perform. It will
Yes.
always be impossible.
And let's also say that Newtonian mechanics does not distinguish.
Let's
here,
cut it
right?
there,
Yes,
Alan.
and so now.
Alrighty.
All right, the key phrase there is, this is impossible to do. It's just a thought experiment. Well, this goes back to Einstein, who did these Gedanken experiments. He would think about what would happen if I were moving at the speed of light. What would the world look like? Of course, he can't travel at the speed of light, so his thought experiment basically is just fantasy, not fact. And that's what they're talking about here. Suppose the stars rotate faster than they do. How will that affect the water in the bucket? Well, who knows? You can't do that. We can't test that, and so it's unfalsifiable. It's the scientific method, when applied here, says that this is a statement which cannot be proven, and it is not part of science. It's unscientific. So they're talking about things which are pure speculation, and what they should be talking about are experiments like Newton's bucket and the Foucault pendulum and others that are relevant to this discussion, and not talking about what if the stars spin faster than they do. I think later on they'll even ask the question, what about if the stars disappear? What will happen? Well, who knows? That's impossible. So my point there is, stick to what is testable, guys. Don't get sidetracked in what you think might happen if something impossible happened.
Gotcha.
Doesn't that kind of apply to all math that goes to infinity then? Any type of proof that includes the term infinity?
Yeah, we could have a discussion about infinity, because that's probably one of the least understood concepts in math, is what infinity is. Anything that's at infinity can't change. Okay, if you had, for example, if you had the number system, the set of counting numbers, and you said that's an infinite set, well, it's infinite because if you try to add any number to it, it's already there. So it's complete. So if the world were infinite, it would be complete. There wouldn't be any event that hadn't already happened. And so it could, because it's infinite, it can't change. And philosophers like Thomas Aquinas have proven that anything that's infinite is unchangeable. It can't be changed. So if the world were infinite, we wouldn't be able to move. There would be no motion. Motion is from one state to another, but you can't go from one state to another if both states already exist. And that's what you have in infinity. So one of the prime things I learned when I was learning both math and physics is that the concept of an infinite world is impossible, because we already see that change is possible in the world that we live in. So this world has to be finite. If it were infinite, it couldn't change. So that's a slice of philosophy for you.
Interesting.
I'm so glad to hear you say that, Bennett, because there was a video. I think you were mentioning Veritasium earlier. He did a video about greater and lesser infinities, and how there's infinities that are greater. There's more infinite numbers between 0 and 1 than there are real numbers on the number line. And I actually posted a while ago in Witz's Telegram group about that, how absurd that was, and how it's just absolute nonsense to say that there's greater infinities than other. I mean, infinity is basically a nonsensical concept to begin with. I mean, you can use it, of course, but you have these people, these thoughts of schools that are basically building off abstractions. They get to a point where, you know, they're arguing over which infinity is greater than which infinity, and it's just nonsense. So I've really glad to hear you say that, Bennett. That's reassuring.
Alan, I love your notes here. You summed this up quite succinctly, a bucket is at rest. A question is posed. A bucket is at rest on Earth, and the universe is rotating at 1 revolution a second, east to west. What happens? Like a word problem in school. Robert Bennett said, nothing. There's no rotation
Dude.
in the lab frame, bro.
Those are from Bennett, bro. He wrote those.
That's awesome.
But yeah, that's awesome. What a great summary of infinities, man. Because they try and use this infinite situation where they use it against you for not understanding that kind of stuff, and they'll even divide by infinity, and it's and get a radius out of it, and then say that everything's collapsing in on that radius.
What's your favorite infinite abstraction, Alan?
I would say the black hole. That's a classic, bro. That really got me invested in heliocentrism.
Well, what's interesting, it was Henry Poincaré who contributed to the theory of relativity. That was one of the major critics of set theory, which set theory is the theory about greater infinities and lesser infinities. And Poincaré, as we all know, was one of the people that Einstein stole a lot of his work from. And he was one of the people that came out and said, this is absolute BS. Hopefully, I think there's like a quote of his that said, like, I hope mathematics recovers from like the plague that is set theory or something like that. So very, very ironic.
Plague. That's crazy.
That's nice. Nicely put.
All right. So if we're ready to move on.
Yep.
Let's see. So we'll go to 47.
Oh, great. They didn't say anything interesting for the next 30 minutes. I totally believe it. Oh, we got no sound.
Yeah, no sound for some reason. You hear
You
sound?
gotta reshare your application.
Oh, my bad. Sorry.
You agreed to do it like 73 times for this presentation.
Sure did, bud. Let's see.
But you see, what we see is the motion of the sun.
Oh, shoot. Hold on. What was it, 45? Or
50-45.
Oh, 50-45? Let's go to 50-45.
Yeah.
Oh, yeah. There was one. Are we skipping the 47?
Oh, did we? Let me see.
Yeah, we were about to start it. We did 25, or we did 26:05 last.
All right, you don't have to show that. You're going to discuss, does the Earth spin on its axis or does the universe? All right. Well, this is another question that can't be answered by kinematics. It's answered by dynamics, and the answer is the lab frame again.
Interesting.
I guess you don't have my response. The question is moot in kinematics because relativity is valid. In dynamics, the universe spins because the Earth must be used to correctly apply the laws of physics. And covariance is violated. One of Alan's favorite words, covariance.
Yes, sir. Yeah. Sorry, I have it up now. It's right here. Yeah. Don't go violating covariance, man. That's the rule book. The rule book. All right. So yeah, okay. So thanks for covering that. And we'll move on to 50-45.
Right.
You got to switch it out, by the way.
What's up?
It
Someone
says
say something?
Yeah, it says stream paused.
Oh, dude, I did it again. GG. All right, here we go. Thank you.
Advanced courses of mechanics, classical mechanics. Okay? And this factor is proportional to the omega square, to the angular rotation of the Earth. So, but then we have once more the question. The Earth is flattened because it is rotating relative to what? Obviously, it's not relative to itself.
But that's for small omega, right? Because if you have the centrifugal force equal to the
Yes, but it is exactly the
it would just
centrifugal
disappear,
force.
right? So
it is the centrifugal force. You are correct. It is the
but
centrifugal.
if this equates the gravitational force, then you have no fluid, you have no solid body any longer. So
yes, you do have,
dissolve and
because
disappear.
only the gravitational force makes the Earth become spherical.
I see.
You add the centrifugal force, it deviates.
Now that's clear. I'm just wondering if that is really, if that formula is really for high omega, that quadratic
Well, he did calculate that for the Earth itself, which is once a day specifically.
I see.
So when you rotate just like the Earth once a day, the amount of flattening is 0.4%. Very precise. But that was only verified 50 years after Newton. And when they did verify it, and nowadays we can even see that from satellites and so on, and the Newtonian calculation is precise. It is confirmed by the observation of the real shape of the Earth. Okay? And now comes the question. What would happen if I let a spherical Earth made of fluid, water for instance, at rest, and consider the north-south axis and spin the universe once a day in the opposite direction? Will the Earth remain spherical, or will it be flattened? Once again, I will let some seconds here for your audience to think about.
The Machians will argue that it's flattened.
Yeah, let's stop
yes,
there,
of
Alan.
course. And how much? Point.
Alrighty.
All right. You see, he's ending there with another question which can't be answered. What if the Earth stops spinning and the universe does? Another thought experiment that can't be verified.
They love the philosophical abstractions reified through mathematics.
They spend a lot of time there, it seems. Yeah, the bulk of their PhD field, you would say.
What they're saying there is that Newton says that the bulge in the Earth, the 4.4% equatorial bulge, is due to the centripetal force, and they claim that that shows that it's the Earth that's rotating, because the water is part of the Earth, and the rotating water creates a bulge at the equator. So that's their proof that the Earth spins.
Yikes.
But I think you have the Æther model there, don't you? Yes.
Yep.
The Æther model says the universal Æther rotation of star time at one stellar day causes a westerly wind rather, of 1,600 kilometers per what?
1,000 miles per hour.
Hour, right. Kilometers per hour, or 1,000 miles per hour at the equator. Now, how does the motion of Æther explain the bulge at the equator? Well, Bernoulli's equation, which is an equation in hydrodynamics, says that the pressure plus the mass density times the velocity squared over 2 equals constant. If you look at that equation, when the pressure goes up, the velocity must go down in order to keep the equation constant. So let's go through what happens when Æther speeds up at the equator compared to the poles. The Æther pressure will be minimum at the equator because the velocity is greatest there. Once the Æther pressure and density are measured, the predicted bulge can be compared with measurement. So you have to plug in the numbers in order to calculate exactly how much bulge will be produced. But the Æther explains by its motion across the water at the equator that the pressure will drop, and if the pressure drops, then the water will rise. And that's exactly what we see. So we can explain with a stationary Earth and a rotating Æther why there is an equatorial bulge in the Earth's frame.
That's super interesting. I don't think we argue for that, but
yeah, I wouldn't. I wouldn't even take it to that far, but I would just, yeah.
Yeah,
It's a good explanation. I would have different argumentations for
yeah,
that.
we don't
for the
try to
so-called
defend
bulge.
Yeah, we don't defend the equatorial bulge, but I've never heard it put quite so eloquently, so that's awesome.
Yeah. Should an equatorial bulge exist, we now have an explanation for it. So
Right?
hell yeah. That's what's up. All right. So was there any afterthoughts on that?
No.
Well, it's consistent with my model of the Earth.
No,
The
absolutely.
explanation that I gave is consistent with an ether is greater at the equator. Its speed is greater at the equator than at the poles.
Yeah, I think we should probably talk about our interpretation of that later, Alan.
Oh, the pulse or whatever?
Yeah.
Pulse wave?
Yep.
Dude, that's so awesome. Yeah.
The proper distribution of motion on our model then.
Yeah. All right. So the 5315, what would we're going to move, or if there's no closing thoughts or nothing further to add on to that, we're going to move on to 5315. It looks like we're already there. Awesome.
Alan?
Awesome.
Uh-oh.
You might have hit the wrong red button.
Yeah.
Dude, sometimes my mouse slides and it goes right to the corner and I inadvertently close Discord, like, alarmingly frequently.
I know, dude. I hate it.
All right. Sorry about crashed.
Oh.
Oh, it crashed?
All right. Yeah, my Discord did. We're good.
We thought you hit the wrong red button.
No. It from swapping menus or whatever a bunch of times. Anyway. We're playing out here.
4%.
Yeah.
Not only will it be flattened, but it should be exactly the same amount as in the real situation.
I see.
And what will the Newtonians say? That the Earth will remain spherical. Why? Because of Newton theorem 31. No matter if the surrounding, because the stars and galaxies, they make like many spherical shells of matter around the Earth.
Okay.
And each of these spherical shells composed of stars or galaxies, the net force is zero on any molecule of the Earth. And it will remain zero when these spherical shells are spinning around the Earth. Because Newton's law of gravitation does not depend on velocity and acceleration.
I see. So this not perfectly spherical form of the Earth is experimental evidence for the
of the real rotation of the Earth. Because according to Newton, if it were the universe who did spin once a day around the Earth would be spherical.
I see.
As it is not. So all the Newtonians conclude that this is an empirical proof that the Earth is really spinning and not the opposite. Because the day and night you can attribute to anyone. Either the sun rises and sets, or the sun is stationary and the Earth spins in the opposite direction once a day. You will see the same phenomena. The same with seasons and so on. But not the shape of the Earth.
So why do you think
the Earth is decisive in Newtonian mechanics?
So why do you think it took 200 years until Foucault made that quite simple experiment?
Quite simple, I don't know, but no one thought about that. And only Foucault,
Foucault's pendulum, we should say that, I mean, it's a pendulum, maintains the, it stays in the same direction, right? And if the Earth revolves, we seem to perceive a change in that direction.
Yes.
And that's many famous Foucault's pendulum exists. So, but Foucault was the first one to do that.
Just to close the question of the rotation of the Earth. So if we could perform the experiment, we could know who is right, Newton or Mach. But once more, we cannot do this experiment.
Right.
But you see, Newton was so brilliant because he found an empirical evidence which happens only in his theory due to the rotation of the Earth. Because if the Earth were stationary and the universe did spin once a second around the Earth would not be flattened.
Right.
But Ernest Mach came and said, this is no proof, because in both situations, the Earth would be flattened. We cannot perform the experiment.
Yes.
But so now we can go to what you said about Foucault's pendulum, because this is also crucial, Alexander. So Foucault made this experiment in 1851.
Correct.
So what is this experiment? I will just simulate it with this pen, okay? Suppose that we are in an inertial frame of reference, and I have a bob here, a string or a thread, and I release the pendulum, and it begins to oscillate, okay? What are the forces acting on the mass? It is the weight pointing downwards and the tension along the string.
Right.
These two forces, they form a plane. So if I release the pendulum at rest, it must always remain in this plane, because the two forces are always in this plane. And I will say that this plane is parallel to this wall here on my side, okay? If we are in a inertial frame,
relative to
the pendulum should always be parallel to this wall, real wall here, okay? But when we perform the experiment on the ground, suppose that I am now at the North Pole, exactly at the North Pole. If I release a real pendulum at the North Pole, parallel to this wall, the plane of oscillation, parallel to this wall here, real wall, I am in an igloo in the North Pole, okay? And there is a wall there, and I release a pendulum, okay? And it parallel to this wall. This is my reference, the ground, always the ground, not an arbitrary observer, the ground. So I have this wall here, and I release it, and it should always remain parallel to this wall, because the weight and the tension in the string, they compose a plane, which is parallel to this wall. But if I am at the North Pole, this is not what takes place in reality. In reality, the plane of oscillation begins to precess. The pendulum is in the beginning parallel to this wall. Then it becomes like that. Then it becomes like that. Then at 6 hours later, it will be, the plane of oscillation will be orthogonal to this wall. Then it continues, then more 6 hours, and then it remains once more parallel to this wall. Then after 18 hours from the beginning, it is orthogonal to the wall again. And 24 hours after the beginning of the experiment, if there is no friction, and if the pendulum continues, but don't stop oscillating, it comes once more parallel to this wall. So the plane of oscillation
to be
precise, of the pendulum,
23 hours
and 56 seconds.
Minutes.
And 56 minutes and so on. So it's almost, I mean, just
talking sidereal versus solar.
Round numbers here, but it
Yeah, sidereal. I think we can stop there, because there's at least there's two ideas. Yeah, two ideas that we have to clear up.
Too much of that hurts my brain, guys. I can't watch a lot of that in like one quick burst.
He must have said parallel to the wall like 7 times, 8 times.
It's like listening to people gaslight themselves. It's insane.
That's so bad. Oh man, okay, I'm good.
Your stream's paused again. There,
oh, right. Oh, my bad. I'm switching back to the other view. All right, should be good.
There we go.
He has to use his hand as a model for the plane of oscillation. So it would help if they knew they were going to talk about this, that they had a diagram or something, not just using their hand as the plane of the pendulum.
Well, when you're in a thought experiment land, you can do stuff like that, Robert, right? You could just ad lib.
Yeah. You can imagine you have a hand, I guess. All right, so they say the Foucault pendulum proves the Earth is spinning, and the reason it's basically the same as the equatorial bulge, that the rotation of the Earth causes the pendulum, which is focused on the stars. It always rotates. It always keeps its plane fixed with respect to the stars. This is their argument then, that it's the stars that determine the motion of the Foucault pendulum. And I'm going to use the diagram that Alan has on the screen now to show what I said before. The red arrows represent the Aether flow, which has been measured. Michelson Gale measured it. GPS satellites measured it. So we know that it is greatest at the equator and 0 at the poles. When the bottom of the pendulum is in its southern position, it receives more Aether wind than when it swings to its northern position. That causes a torque, a twist in the plane of the pendulum, and that causes it to rotate, and the amount of rotation depends on exactly what latitude the pendulum is located at. So I've just given you is the Æther response, the Æther model response to what you just heard from André Assis in terms of explaining how this happens with a stationary Earth and a rotating Æther. Let's see if there's anything else. Anything else there?
So that's what we were saying before when we started off with. Yeah, we can say that loosely a translation of the motion of the Æther relative to your latitude is what's interfering with the pendulum to make it precise.
Yeah. Well stated.
Would you say there'll be different effects on the pendulum at different latitudes? Like
well,
different
there's a
Æther
change.
effects?
Yeah, the Æther effect that's visible is the rotation of the plane of the pendulum.
Would it have different rotation at different latitudes? Is what, like, I'm just curious.
Oh yeah, sure. That's been measured.
Or wait, did you say? I think he said altitude and then he said latitude. Am I wrong?
No, I meant latitude. Like latitude.
Oh, my bad then. Sorry.
So ground level, I guess. I mean.
So right at the equator, it shouldn't precess at all then, since that's the no motion for you.
Yeah, that's right. If it's exactly at the equator, then you'll get the boost in the north and the south position, which is about the same.
So no
but once you
precession.
start moving, and by the way, here's a test for you. What if I move the pendulum into the southern hemisphere? What does it do?
It should precess inversely, but the first test that they did, they had it backwards and they didn't know that.
What do you mean backwards?
Well, I thought when they lined it up, they thought it was precessing as it would in the north, but then they were like, oh, we made the wrong relative corrections because we forgot we're in the south.
Well, it will rotate counterclockwise. And if you think about it, that's the same as what? The weather systems, right? The low pressure systems rotate, let's see, counterclockwise in the northern hemisphere. And the high pressure systems rotate clockwise. And it's just the opposite in the southern hemisphere. So what is a logical conclusion? Logical conclusion is that the weather systems are being influenced by the Æther flows. And they're rotating just like the pendulum does.
Is that the same for the Coriolis effect then? Underneath, say, a bullet or whatever, you're saying that when the sniper fires the bullet, that the Coriolis effect is actually an Æther wind pushing against it?
The Coriolis effect is the mainstream explanation for what I just explained to you using Æther motion.
Right. So my question for you, Robert, if we were to, according to the Æther model, if we were to go to the equator, right, what would you surmise to basically best line up yourself with that center point, right? That equator? Would it be the celestial equator or geographic equator? What would you get? Like, where would you want to set it up if you had?
At the Earth's equator, halfway between north and south.
Right, that's where Whitsitt is trying to do his experiment. He's getting it all set up. He's been talking about it for a while. He's trying to get the Foucault's pendulum right at the equator. The hypothesis being it will precess the same, and then that will counteract the claim that it shouldn't precess at all.
Oh, I didn't know that.
Oh, I didn't know that either.
Ask him what happens if you set the motion east-west initially.
Ooh.
Whitsitt, he's here.
I don't know if he's really here though.
He's probably just listening. But I didn't know that. No, I was just curious about when you say the Æther, right, causing the drift, right? Would it be best to line up with the celestial equator or the geographic? And you say geographic. Okay, that was my question.
Yeah, geographic. And my question was, what if you start the pendulum not north-south swing, but an east-west swing?
I mean, then in theory, it should just stay straight, right?
Right there, right? It should.
Yeah, I was gonna say it should cancel out, right?
And that's exactly what happens most of the time.
Ooh.
Oh, GG.
We have to do that. We gotta do it.
Yeah, we do got to do it.
So is it essentially that all fictitious forces are actually just Aether forces, essentially? Or all claimed fictitious forces caused by the globe spinning around are actually just the effects of the Aether?
Yeah, misinterpreted. Yeah, I would say ether measurements for sure.
I would agree with what you just said, except I would say all inertial forces, not all forces, all inertial forces. And what are inertial forces? Ones that obey F equals ma.
Force equals mass times acceleration.
Newton's second law.
Gotcha. Let's continue.
Like a big part of our whole position, though, is that like all the measurements of proclaimed Earth rotation have only ever been misinterpreted measurements of ether wind, for sure. That's
Right.
definitely my position.
Same.
Which is what they like to do, is they invert reality or reverse engineer something like that. Yeah.
That's exactly how they got thanks, Bob, out of the inversion of the actual data and the truth, right?
And that's why they could never, ever let him talk about the z-axis measurements.
Yep.
So where is the ether wind the strongest? At the equator or at, say, closer to the pole, North Pole?
The ether wind that we're talking about is the same ether wind that carries the stars and the galaxies around the Earth. All right? When it's at that distance, the speeds are enormous. So more, enormous times the speed of light. As you can think of this ether as a giant, solid piece of steel that's transparent and that you can easily move through. Mass can easily move through this ether, but the masses that are stuck in it in outer space are stuck in something solid. So everything rotates around us as a solid, except inside the solar system. I think if you go back to the scientific propaganda slides, I showed you that there was a theory by Hildegard in the 12th century, explained the difference between the rotation in the solar system and outside in the star system due to contrary winds that slow down the motion of the planets.
Right, that was the difference in speed and velocity in the background ether between the wandering stars and the static stars, because the wandering stars have perihelion shifts and all sorts of crazy loops that we have to explain, and the geocentric way to explain it. And then with the ether wind, we can say there's other outwardly winds slowing it down to account for that. That was super cool. I remember that.
And ether is zero at the center of the Earth, right? And then you have expanding circles of increasing speed, rotating as if the ether were rigid from the center of the Earth all the way out to the distant galaxies, to whatever they now claim as 13.6 billion light years as the radius of the universe.
So when you say as if it were rigid, you kind of mean like the face of a watch?
By rigid, I mean that when anything moves, any part of a rigid object moves, the whole object moves.
Okay, so like watch hands,
clock
hands.
Yeah, exactly.
Yeah.
Cool.
Or like anything we call solid.
Cool. So that kind of.
If I push on.
Oh, go ahead.
If I push on any solid object, the whole object moves, not just the part that I pushed on, right?
Hmm.
Right?
Yes. Yeah. Oh, yeah. Yeah.
Okay. And a liquid, of course, wherever you push it, that will be deformed, but that doesn't mean the rest of the fluid will move. So that's what I mean. By rigid or solid object, I mean that it never changes its shape.
Gotcha.
Interesting.
There's the model for that Alan had, the Hildegard model, and those black lines are the jets of ether coming from the stationary stars, and they're aimed at different parts of the solar system, and they slow it down. So the speeds in the solar system are slower than they are in the star system. The stars actually move faster around the Earth than anything inside the solar system.
But that's only especially true in your conception because of the great distances involved, where our interpretation is somewhat more localized. Therefore, would be then wouldn't necessitate such a high speed at such a high velocity way out there. How many billion light years out?
Well, let me say that I'm quoting mainstream, right, as saying 13.6 billion years. I don't believe that the redshift is a Doppler shift, and I don't believe that the stars are receding. I believe they're stationary, and so they could be, you know, 100 light years, not billions of light years, and they're not receding. There's no Big Bang. There's just a stationary Earth, just like God created it, stationary.
Right, I agree with most of that.
I'm just how does the stars moving around us at these insane speeds, all in lockstep in this ether, how does that translate down to the ground, into the pendulum, is what I'm trying to kind of understand.
Well, the speed of the ether is 0 at the center of the Earth, right? And then it spins faster and faster as you move away from the center of the Earth. And the motion is cylindrical around the poles. We're talking about the rotation around the North and South Pole. And so when you get to the surface of the Earth, it's a certain speed. It's 1,000 miles per hour at the equator. Now that number should be familiar. That's what mainstream says is the rotational speed of the equator for a rotating Earth. What I'm saying is the ether is rotating at 1,000 miles per hour at the equator, and the Earth is stationary.
Oh, correct me if I'm wrong, Bennett, but you also believe in the alleged radius value of 3,959 miles as well?
3,900.
You believe in what they say the circumference is and the radius and the diameter, 24,000 something miles in circumference.
Well, okay. If I believe that
like
the
you
radius
believe in
is
the
60,
given dimensions of the globe, is what I was asking.
6,400 kilometers is the radius. Yeah.
Okay, gotcha. So you do believe in the radius value. So wouldn't the ether rotation have to be at a much greater velocity the higher up that it would be? Or are you just saying that it rotates at 1,000 miles at the roughly 1,040 miles at the equator near ground level is what you're saying?
Right. And it gets faster as you increase altitude.
Yep.
Okay, gotcha. And it gets faster as you increase
That's
altitude.
That's what Bob's measurements prove. That's what this proves. The Earth being the source of that motion.
Right. And now the what I was interested in is the speed though. Now you're saying that you believe that the ether winds themselves are around 1,000 miles per hour near ground level, but the from what my understanding, and granted I haven't dipped into Miller's raw data, but I have read over Elias's breakdown of that data, and he seemed to imply that much greater speeds on the order of around 8 kilometers per second. Is that something that you would refute, that it was, or that you would deny that it wasn't actually that fast? There was something wrong with the scale that they were using?
Well, the number that I've memorized is 1,000 miles per hour. I don't know how that converts to kilometers per second, or it's probably around 8
kilometers a second is about 17,000, 17 to 18,000 miles per hour.
Okay, so that's almost twice as much as at the equator.
Well, no, that'd be 17, 18,000 miles per hour was the fringe shifts that Miller had claimed to measure, at least on their maximum dimensions near the equinox. So that would be I was just asking for your input on that. So if you were saying, because that's actually what I used to be arguing as well when I first encountered yours and Sangenis's work through Witsit. Actually, it was his geocentrism presentation that led me to a couple of videos by you guys, and I had taken that to mean I was arguing, yeah, the rotation of the ether, and that was one of the main criticisms that I had gotten that I didn't really have an answer for a while, which was why the fringe shifts were measuring much higher than 1,040 miles per hour near the equator, because according to Miller and subsequent Michelson-Morley experiments, they were measuring the fringe shifts at around 8 kilometers a second, which would be about 17,000 something. I forget the exact what that translates to, but around 17 to 18,000 miles per hour. So I was wondering how you would square that with the ether wind speed that you were asserting.
Okay, I know what the confusion is. The number that you're quoting, 8 kilometers per second, is the average speed of the ether as measured in the MMX experiment by Miller.
Yes. Yes.
Right? Yeah.
Yes. Yes. And correct. Yeah.
That I agree with. But what we're talking about is the speed of the ether around the Earth at the equator, which is not the speed of in the difference between the speed of light measured in perpendicular directions as it moves through space. We're talking about two different measurements. One is the measurement of the ether speed around the Earth. The other is the alleged speed of the ether of the Earth through the ether.
Oh.
Okay. At mainstream claims that the MMX result was null, meaning 0, which is misstatement.
Right. Well, they attribute it just to instrumental error, which is pretty obviously false if you look over Miller's work. But then, what my follow-up question would be: how would you go about measuring that 1,000? I mean, other than just looking at the sky in sidereal rotation, obviously you could assess that it would be 1,040 miles per hour at the equator. But how would you go about using laser interferometry to confirm that figure?
Well, I showed a slide when I gave the SciProp talk of stationary, not geostationary, GPS satellites had already done this test in a giant Sagnac loop. They sent out light beams in opposite directions at the same time, and the time that it took for each beam to return. And they followed the same path because they were relayed by 4 or 5 satellites. And what they found was that the speed of the ether is proportional to the distance from the Earth, which is exactly what I'm saying. The ether is rotating like a rigid body. Now, has it been done on the equator? I'd have to look at the documents to see if ether has ever been tested for its speed on the equator directly.
So if it's a rigid structure and that radius value holds true, if we're getting a 1.3 degree per hour variance by going up 4,000 miles, doesn't that kind of not line up with your radius value, if that were the case?
Gentle push.
Well, I don't know I don't know what it should be after going up 4,000.
Fair, very fair. But I would think it should be pretty minute per hour.
So, I mean, like that would only refute their position, not his, right? Because his position is rotating Æther, stationary Earth. They would have to. The only if that motion is caused by the Earth rotating tangentially, does that negate the Earth rotating as the source of the motion? So it doesn't actually hurt his position.
Well, it would have to be rigid in a 3D sense, going out from the center, right?
No, not 3D. 2D.
2D. Oh.
It's rotation of a cylinder, not a sphere.
Oh. Okay. Okay, that helps me. Okay.
Rotation is around the north.
Okay. That's
rotation
interesting.
is around the north and south pole, not the center of the Earth.
So okay, so there's no spherical shape to the rotation that you are measuring.
No.
Okay.
No.
Huh, okay.
For example, the speed of the Æther is 0 at the North Pole and South Pole.
Well, doesn't that make your stars are drastically different in coordinates than or in distance? I guess you'd have a lot of different distance calculations, even relative to each other, in comparison to the heliocentric model, correct?
Yeah, once you get rid of the redshift as the explanation for the motion of the stars and their distance, then you really don't know what the stars are doing. They could easily be at rest, and they could be producing Æther as part of the light that they emit, so that the light is riding on a current of Æther as it comes to us. And the math shows that gives you the same prediction as the Doppler effect. It shows that would be a redshift if stars are emitting Æther, and of course they can't. Well, they could absorb Æther, but it would be locally, not globally.
I got a question, Robert. So if you're saying at the poles the Æther went 0, would you say that then it would be again the difference, sort of like the Earth spinning at 1,040 miles per hour? It would tangentially be different as you go up in latitude, like from 900 to 800 to 700. Is it the same principle with the Æther wind?
Yeah, I think the formula is what is it? The speed of the Æther at any latitude is the speed at the Æther times the cosine of the latitude angle.
Okay.
Right. So all the way around the Earth at that latitude, the speed will remain constant of the Æther wind, right? Same thing.
Yeah, at the same latitude, the Æther speed is the same. Yes.
That jives with my understanding.
Okay.
Yep.
So no matter where you are, in terms of like on the let's say 66 degree latitude north, right?
Yep, swing that.
Yeah, anywhere around on that latitude, same speed, same Æther speed.
And the stars are a shower head emitting Æther that's flowing down. Think about it like a watch hands.
Yeah.
And the stars are going in a circle. They're emitting the Æther down, and the Æther flow that we exist in comes from the stars.
Hey, it's like Bisland's model though, like latitude dependent optical phenomenon. Same thing with Æther speed.
Yep, relative to the laddie.
Since we're kind of on the topic, actually, Bennett, a question that I actually was really itching to ask you in your last Q&A. I know you had kind of addressed it a little bit. There was a quote presented to you, which was, I think it was misquoted in this stream, but it's millionaires don't use astrology, billionaires do. And that quote was actually spoken by none other than J.P. Morgan himself, one of the most powerful billionaires in existence. And then, if I heard you right, you also said that you believe that all matter is ether. Is that correct?
Yep.
Different
Yes.
forms of ether, and you believe that the stars and the placement of the celestial objects actually have a direct effect on the ether winds themselves.
Yes, there are
So,
16 stars. Yeah.
so I just wanted
Go
to
ahead.
actually I just wanted to get your clarification on. You had also definitively stated that you don't believe that the premise of astrology is at all accurate, and that this position of the stars have any effect on our lives, physically or mentally or any other way. I was wondering if how that would, if you do believe that the positions of the stars have a direct effect on the ether wind, and everything in existence is made up of different forms of ether. Why that was very interesting to hear that you completely reject the premise of astrology. Maybe you could speak just a little bit more on that.
Yeah. Well, if I did say, if I didn't include that my belief in astrology that the date of birth determines your fate, basically, in life, what will happen to you can be predicted by not just the date but the time of your birth. That I don't believe that has any basis in science.
Well, that's definitely more of like kind of a pop astro. I was just talking about just the raw premise, like the actual, just the assertion that well, like, like in ancient times, many of the ancient cultures, they attributed personifications to the celestial objects, right? Mars is, say, for instance, the god of war or something like that. And if you can kind of show that the positioning of the celestial bodies has a direct effect. Again, going back to even Miller's work, where he proved that sidereal time is directly related to the speed of the ether winds, then it kind of could make sense. At least that's kind of how I made sense of it, is that these ancient cultures may have been attuned to something of the sort of these celestial objects resonating their own kind of their own magnetic field or ether field, if you will, and that affecting each and every one of our, since we're all made of ether, all of us, and maybe those that could have a direct effect on the thoughts, actions, and social conduct of the masses at the time. I was just wondering what your thoughts on that would be.
Well, I won't deny that the ancients were influenced by the position of the stars and so on. Okay, but I was speaking from the logical position of a scientist who would require that there's experimental proof of this. I mean, if you go back to what the ancient belief was in the position of the stars, you can analyze the zodiac, right? The 12 signs of the zodiac, and it has a religious overtone because Leo the lion is next to Virgo the virgin. That's consistent with the Christian belief that Christ, whose symbol is Leo, was generated by the Virgin Mary, who is the next sign, Virgo, in the zodiac. So the stars had influences in religious terms in ancient times. But as far as Hildegard is concerned, she's saying that the motion of the objects in the solar system is determined by the rotation of the universe as a whole, minus the ether winds that are generated by these 16 stars that slow the planetary objects down, the sun and the moon included. So based on that vision, I've built a model which is consistent with what we know experimentally today. So, do you have any more questions about astrology?
No,
I'm
that's
not that
fair.
familiar.
No, that's fair enough. I was just wondering if just broadly speaking, what your kind of thoughts on that was. I know you hit on it a little bit in the past stream, and I was just wondering if you could expound a little bit more. But it totally, I totally understand what you're saying with regards to coming at it from a scientific perspective and wanting more in-depth experiments on it. So thank
Yeah.
you for answering.
Yeah, I think I asked him about that before. I get where you're coming from. I was kind of curious too, but it's kind of like we have different interpretive frameworks for that as well. Like if you're still of the belief that they're just like balls of rock hundreds of thousands of millions of miles away floating around, it's hard to believe that those things have any sort of influence on your life or reality. But if your interpretive framework is you don't know what they are and they could be some sort of sonoluminescence or positive interference or some sort of spiritual thing, then your interpretation of them influencing your life is a little bit more realistic. But we don't need to go there. It's cool.
Yeah, for sure. And I did like Bennett. I did like what you were saying about the possibility that they could be angels and lesser than that. That was all very fascinating. So, yeah, really good stuff in the last stream on that. Thanks for going into detail.
Yeah, well, I'm glad you remembered that. Yeah, we really don't know what those lights in the heavens really represent. We think they're suns, just like our own local sun. But if you go back to Scripture, the description is of a greater light and a lesser light, the sun and the moon. And then, like an afterthought, Scripture says, and he made the stars.
Also,
it's
right.
like
and all the rest of the stars too. Yeah, it's like
yeah. It's like oh yeah, I forgot. I also made the stars. It's like the stars aren't that important, but they do play a role, definitely.
Well, you won't find very many people on our side of the fence, Christians or non-Christians, that would assert that the lights in the firmament are just distant suns. You know what I mean? And in fact, yeah, no, I totally vibe with what you're saying there. So a lot of mysteries still yet to be discovered, and probably answers that we'll never get in this lifetime, but is nonetheless really fun to speculate on.
Right.
It's funny. I do remember that though. He made the stars also.
Yeah, I think you were the one that read it. We were going over it. Like, isn't that? It's a definite afterthought. Interesting.
Yeah, it's some extra time and just did it. All right. Okay, so do we want to pick back up on the Assis?
Yeah, I hope we're getting close to the end, right?
Yeah. We got. Let's see. We got 1, 2, 3, 4, 5, 6 more Azises, but these are all kind of close proximity, so we could probably bang them out pretty quick.
Yeah. What's the next one? 104?
The next one is 5655.
5655.
Oh, let me bring it up here.
56.
You have to keep following the many steps that you said you would.
Yeah, let's
is it
just
not
do.
sharing properly?
Oh, you got it.
Okay.
What we could do is do 56 and just do that one, and then do the last 4 or 5 all together.
Awesome. Okay, yeah.
They're close together.
Cool. All right, so 56. It's a funny story. We're already ahead and I listened to it before we paused. So do you just want to give your input on it?
Okay, you already covered it, right?
Yeah, we already played it through.
The pen with the parallel wall.
Yeah.
Right.
Oh, I was behind. My bad. I must have been behind. Okay, so yeah, we're on 104 to 1. Yeah, we're at the end here. This is the home stretch right here. So let's bang these out from 104 to 112, and then we'll just hit them all in a row.
Yeah.
All right, boys, we're going in. But we're going in really fast.
Chemically determine what is absolute space at rest, right? And this is a local experiment. You don't look at the universe and say rest is the system, the frame in which I don't perceive any centrally.
Yes, there is no curvature of
but you don't
water,
need the
no
rest of the universe.
flattening
For
of the
Newton's
earth.
theory, it doesn't make a difference.
Yes.
And then you have another method, of course, to determine what is at rest. Look out there in the stars. I mean, back then you had stars. Now we have even quasars, even better.
Yes,
very precisely, and that is what is done. Yeah. So I don't know how many digits accuracy. And you observe this and say, okay, observationally, this is my unaccelerated system at rest, which does not rotate. If I look out there, so very precise. And what a coincidence that these two systems coincide. I mean, it's a coincidence. It's an unbelievable coincidence, and very. I mean, and the startling thing is, and it's irritating that Newton does not explain that coincidence.
Yes, of course. No one.
Yes. Also, Sharma in his paper said, yes, Newton does not explain that coincidence.
Yes, not at all.
Should make us worry. I mean, the very foundations of Newton mechanics. And by the way, general relativity does not resolve the problem.
No, not at all as well. And if you see, if we go back to the Foucault's pendulum, if I am in the North Pole, the pendulum follows the motion of the stars. If I am in the South Pole, when it rotates anti-clockwise, but as I myself am now upside down, also in the South Pole, the pendulum follows the motion of the stars and galaxies, because in the South Pole they move anti-clockwise. So,
and why should it? Why should it?
Yes, why should it?
Prove that it does not. There's no gravitational influence. That there must be something else, or let's say, an understanding of gravity which goes beyond that Äther square law, which is also the so-called constant fixed part in big G that questions that constancy of the big G, because there must be a deeper law behind which in first approximation is fine and wonderful, but it's not the end of the story. Yeah.
And so if your audience, if they just think about these 4 experiments and of its 4 consequences, which are very different in Newtonian and in Machian mechanics, that will be wonderful, Alexander, of our talk today.
Yeah.
Because maybe we should even have more like short experiments. What would happen, for instance, for the flattening of the Earth, if we could annihilate a magic like that, and all the stars and galaxies disappear from the universe? Okay? the Earth is spinning once a day, and if we wish, we can let only one star very far away to be our reference, so that the Earth remains spinning relative to that faraway star. But all the other stars and galaxies disappear from the universe. So the question is, will the Earth remain flattened at the poles 0.4% as Newton calculated, or will it become spherical? It is still spinning once a day, and relative not to an abstract frame of reference, observer, but relative to a real star. But we make magic and we annihilate. It's not that we put far away. They disappear from the universe somehow. Okay? Another thought experiment.
Dude, will it become a sphere, or will it become more spherical than we already thought?
That creepy.
Those are your 2 options, dude.
That was so
but
weird.
It is very deep, because then we can think about the consequences. So what will Newton would say and Mach would say? The answers, they are opposite. According to Newtonian mechanics, nothing will change. As the Earth still rotates once a day, it will remain flattened by 0.4%. According to Ernst Mach, on the other hand, the amount of flattening should depend not only on the rate of rotation of the Earth, but on the amount of matter which is outside the Earth.
Of course,
that's the question. And there is only one star, the Earth will become essentially spherical. Still spinning relative to that faraway star, but it should become spherical. Any theory implementing Mach's ideas must lead to this consequence.
Maybe we should clarify another thing, because people know about Einstein's general relativity, and sometimes they're not clear about that, since Einstein was inspired by Mach. Demonstrably, there is an exchange of letters, but Einstein's general relativity nonetheless is not Machian.
What's that?
It's like some people aren't clear on general relativity. Oh, but this group is especially clear on it, though. Thanks.
Not at all. Not at all.
Because the problem we mentioned here, this coincidence of frames, is not explained by general relativity, and maybe even more importantly, also the gravitational constant is not explained by general relativity. It's taken as a constant. I mean, he prefers to put it as kappa. That means AT divided by AT divided by c to the 4th power. However, Einsteinian theory still considers the gravitational constant as a constant.
Yes, exactly.
A God-given number, and that is unsatisfactory. And ironic, by the way, because Einstein complained about God-given numbers. No place in the fundamental theory of physics, and he puts the very God-given numbers.
And the same as regards light velocity as well.
Okay, so we should make sure that it's not, because someone might think, oh, that's all resolved with Einstein. No, it's not.
It's not.
Unresolved.
And if you allow me, Alexander, just to complement your comment here, which is very important, that Einstein's general theory of relativity was inspired by Ernst Mach, but in the end, he did not implement Machian ideas. And Einstein did visit Ernst Mach. I believe it was in Vienna. Yes, it was 1913 or so.
I think it was an exchange of letters.
They did have exchange of letters, but he did also went there personally.
Einstein appreciated Mach very much.
And he did meet Ernst Mach, and then Ernst Mach died in 1916. But Einstein did send him just almost final general theory of relativity by letter, and sent it to him, and Ernst Mach had the opportunity to read it, essentially the general theory of relativity. But then in the last book of Ernst Mach, The Principle of Physical Optics, which was published only after his death, but then in the preface of this book, Ernst Mach said that he was not accepting the present Einsteinian theory of relativity. He understood it. He rejected Einstein's theory of relativity. So his ideas did inspire Ernst Mach. But what was made by this theory is not my ideas. They are not. He rejected them.
He was very reluctant. He was also a little bit annoyed, even that he felt a little bit used as a popularizer of relativity, and didn't like that at all. However, that you might consider that a historical detail, and I mean, Mach was very old, but I think maybe. I mean, there are some things in common, but you can distinguish. It's interesting to distinguish the 2 approaches by Einstein and Mach. And Einstein, if he talks about relativity, Einstein talks about systems of reference.
Yes,
He says if one system moves relative with constant velocity, there ought to be the very same laws of nature and so on and so forth. And then he talks about these frames, these inertial frames moving with constant velocity relative to each other, and then extends this thought to accelerated frames of reference. But he's always talking, let's say, with these mathematical concepts of frames of reference, and then you have groups and Lorentz groups performing operations on these frames and deducing or postulating the validity of laws of nature. The idea of relativity put forth by Mach is different.
Yes,
when he says relativity, he always talks about a relative motion.
Yes,
okay, that's the central concept, and he says that it doesn't make sense if we have any law of nature depending on absolute motion with respect to whatsoever, but everything must depend on the relative motion of the particles. And in turn, also a big step, depend on the relative acceleration
of course.
of bodies. And that's the tiny little difference how Einstein and Mach use the word relativity. They're both relativists in the sense, but they use it differently with also different outcomes then.
If you allow me, I will just make my last comment because I think we have already almost 1.5 hours now.
No, it's fine. I mean,
but I think
you can switch off if you're too boring. But
no, but I just mentioned two things. So for those of your audience who have an interest, my own work, I have there is this one which you presented about there was these two buckets in the cover, but I have a much larger one, a much deeper one. The title is Relational Mechanics and Implementation of Mach's Principle with Weber's Gravitational Force.
We'll display that.
And it is available in PDF in my homepage. I hope you will put that in the description
in the comments. You find it
of the video. And so there, people can find a mathematical theory based on Weber's law, which we spoke.
That was my question. The question was I wanted to ask you.
But I think that's not today. Not today. Maybe another day. But
yeah, but I mean, if interesting, if you just given a little idea. I mean,
maybe
so nicely links to the other video because I can display Weber's formula, how he modified Coulomb's law, and there's a deep analogy between the gravitational and that's what inspired you.
If people just to go to the previous talk that we discussed Ampere and Weber, that will be enough. Just to close. So I came this time to Germany, as I said in the other video as well, by an invitation to work at Augsburg University on the 5th volume of the English translation of Weber's main works on electrodynamics. And the 4th book that we did publish already has
Alan, I don't think we need any more.
Oh, thank God.
Oh, God.
I was waiting for you to pull the plug.
Yeah.
Awesome. All right, let's get that off the screen. I gotta take
someone
a
else's
shower
book
after
now
that.
and shit. Everyone, let it flow.
All right, here we go. So I'll make this big size. 28 color. All right, so a lot of interesting stuff said. We'll go from 104.
Okay. Alexander said that dynamics determines absolute space. Well, hopefully we have learned that dynamics requires that you use the lab frame if you're going to make any predictions.
All right, so
Newton's bucket and Bennett's hiker. You remember that? That's the example I gave of a accelerating car on a highway and the relationship of the hitchhiker to the driver's inertial force. In that example that I gave, the same postulate holds true. The reference frame that has to be used to predict what is the inertial force on the driver or on the hitchhiker is which one is in the absolute frame. And the hitchhiker is the one. Yeah, no, it's not that. There it is. The one who's the in the lab frame, the hitchhiker, correctly predicts the force on the driver, but the driver does not correctly predict what is the force on the hitchhiker. Reason is the driver is not in the Earth's lab frame. So that was an example that I gave, which is similar to Newton's bucket, but it's not rotation, it's linear motion. Just like Sagnac and Wang are related by one as a rotational example of Æther rotation, and Wang is a linear example of Æther motion. Okay, Andre asks, what if only one star is in the sky? Well, if the Æther is still present, the phenomenon still remains. And this is still, once again, an example of something which is impossible and doesn't come under the scientific method. It's not something that can be tested. Mach's principle conflicts with general relativity. Yes, general relativity actually is a bogus science. because it claims that it can predict dynamics, but its name is relativity, so it is only kinematics. General relativity does not include the lab frame as being the absolute reference frame. Mach rejected general relativity. Yes, and he did well in doing so. So they're both correct. General relativity is a misnomer. It is actually dynamics, not relativity. It's based on general covariance, which is not true. It violates the alpha model of absolute lab frame and fluid ether. And the laws of physics, which are derived from a variational principle, are only valid for an Earth observer, which is an example of frame dependence. You may hear the term used, frame dependence. If something depends on where the observer is, then it's frame dependent. And that's definitely true for the lab frame. And then finally, Alexander says, think about the 4 experiments. You can use either Newton, Mach, or a third model. And of course, I'm using the third model, alpha. Mach's principle is a problem to solve, says André. No, Alexander said that. And I followed their advice, as the note says. I sent them a letter. One responded, the other didn't. And at the end of that tape, you saw André describe his book, Relational Mechanics. I have a copy of that, and I'm going to put a critique of that in Vixra. And that's what I'll be working on for the next week or so.
That'll be a good video. You should put that in a video.
Yeah, we're looking forward to going over that with you on, or if you want, we can, when you release it, we could do a video on it if you want.
Yeah, well, that's too much detail that I have to go in, and also it's a description of a text document. You'll notice that what I presented here is a something with a lot of video content, because we could listen to the 2 mainstream, or actually they're not mainstream, they're dissidents, and they propose different views of Mach's principle. And then we commented based on what we saw in the video. So that makes it more adaptable to a video presentation. So I'm going to put the document in Vixra, but if you do want a video presentation, I could maybe do that in the future.
All right.
Cool, man.
Nice.
Yeah.
I just want
Either
to see
way,
the
thank
first
you.
Bennett produced video. Yeah.
That Bennett production, dude.
Well, I've got a video editor, right?
That's right. Now you have
You got
no
several.
excuse. You have to become an expert.
Yeah.
Indeed.
All
You
right,
definitely
that was
have.
awesome, man.
That was
you definitely
terrific.
have an editor.
Yeah, thank you, Robert. Appreciate it.
Yeah, maybe I should just
Yeah, thank you
summarize.
so much.
Yeah.
So a quick summary would be, Mach's principle has generated, since it was proposed, let's see, 240 years ago. Okay, it was in Newton's Principia that this was first proposed by Newton, and it hasn't clearly been answered, as you can tell. You have different responses to what the solution for the explanation of Mach's principle. Newton said it was absolute space, but he didn't tell us where to take the measurements. So it was like saying it's a mathematical situation that I can't describe physically. And Mach said it's the stars that influence this, but all we have to do is realize that I can predict only by where the observer is what the result of the experiment will be. That is, if you were in the lab, that is on the surface of the Earth, stationary, and you make the measurements and use the measurements there and apply them to the laws of physics, you will get the correct answer. If you're in motion with respect to that lab frame, that is, you're in a non-inertial frame of reference, your predictions will be false. And I think that's the main content. There's three theories of Mach's principle, and I'm adding the third one, alpha, as a counter to the first two. I think that summarizes what the situation is. Okay, thank you for listening, and
Yes, thank you.
Yeah, that was great.
Yes,
That was
You're
fantastic.
welcome anytime. We do this once a week now, so you can anytime you're feeling bored, you stop by, have a nice chat.
Yeah, thank you, Robert. And you're
Yeah.
definitely alpha.
Yeah,
not,
lots of love and
not a
gratitude,
beta.
man.
Okay,
Yeah,
guys. Good luck. Good luck in your search for the truth. Let's hope we find it together.
Hey, amen to that.
Thanks for all your
Amen to
help
that.
along the way, man.
All right. And I'll be sending you an email, Alan.
Okay. Yep. Yeah, absolutely.
Okay? That's a follow-up.
Yep.
Okay, guys.
Sweet. Thank you
Take
again,
care.
Robert.
Goodbye for now.
Have a great night.
Bye now.
See ya.
Take care, Robert. Go ahead and disconnect him. Okay.
What a legend.
Okay.
Yeah. We have to boot him
Should we
right
go ahead
face
and
in
cut
front.
our live streams, Alan? Anything you want to sum up, or?
No. So just the importance of the lab frame again. I mean,
Over and over and over again.
It's just like when he emailed him all those critiques, it's like the reason he didn't answer him back is because it all goes back to this same thing. Everything that guy tried to avoid and build his, false theory on to usurp another false theory, reduces back to ash when you look at it. And that's why you can't answer it. That's why when you approach it with sense, they call you crazy, like Chris was saying earlier. They'll start calling you crazy, because you're not acting like them. And that's really what's happened here, man. It's like the world stopped spinning for us, and now we're the crazy ones. Right?
Yo, and shout out Fe Caleb if you're out there listening. I know you were hounding on this in your recent debate, and it really is as simple as that. Like, it really is as simple as the fact that everything just keeps going into theoretical fantasy land.
Yeah, that whole paradigm is there. But as he was talking about, like, if your whole paradigm is thought experiments and you can just sit and make shit up in theoretical fantasy land and no one ever checks you. In fact, if your whole PhD is dependent on living in fantasy land, then, you can just do stuff like that.
Yeah, when
Thought
a
experiment.
man's income is dependent on him not understanding something, he's more likely to never understand it, and that goes for all the PhDs. That's why I was giving him so much props at the beginning for being a PhD and actually going against the grain. I mean, that takes balls, man. That's he's an absolute legend for doing that. He knew exactly what would happen, that he would face social ostracism from his most respected peers, and he did it anyways. So
I'm trying to figure out, did he do
up.
it in his prime, or did he do it after he retired as like a final fuck you?
Oh, he said straight up he's retired, so it makes it easy.
Well, no, but like, did he go against the grain
that's
hard
a good
while
question.
not retired? Is my question. Yeah.
Yeah, I don't know. Alan, do you know?
Because I thought that he kind of only after he was retired was like, okay, here's the deal. Fuck everyone. Fuck you. You're cool. Like. Here we go.
That was definitely interesting.
All right, yeah, let me wrap up my stream here. Then I'll be right back.
Cool. I'm going to go ahead and also cut the Æther Cosmology live stream as well. Thank you so much, everyone, for listening in. I hope you got something from this. I know I sure got a lot. It's always fantastic to have Robert Bennett here. It's always fantastic to have everyone here that's contributing and listening. And I hope we can keep these going for a long time. And also, I hope to increase production value in the coming months.